Good evening. We are studying bridges, right? In that bridges, we have taken two topics. One is low resistance measurement and medium resistance measurement. In that medium resistance measurement, first topic we have taken VA and AV method. Just I'm brushing up. Here, low resistance, medium resistance, high resistance. What is the range of low resistance? Less than 1 ohm, 1 ohm to 100 kilo ohm, and high resistance, which one? Greater than 100 kilo ohm, greater than 100 kilo ohm resistance. Right. So after that, low resistance measurement is by two methods. I told you. What is that? Potentiometer method and KDB. Undoubtedly, these two are ultimately highly accurate. We can say these two are ultimately highly accurate bridges. Why? Why? Already low resistance we are taking that too. One method is with potentiometer. One method is with potentiometer, and other is with KDB with including the contact resistant drops. Therefore, both are equally good. So no need to worry. Right? Okay, next. So medium resistant, there are four methods I told you, right? One is volt ampere. Nothing but voltmeter ammeter, volt ammeter voltmeter method. Okay. Other than that, substitution method, Wheatstone bridge method, and ohm meter. These are the methods available. I told you, right? Only one method we have taken, right? We are going to see all this. So what is V and AV? Same method of power measurement as it is. What is that? VA method and AV method. One second. VA and AV method, right here. Sir, in this VA and AV method, what is a simple idea? VA method, error is due to ammeter. AV method, error is due to voltmeter. And AV method, right, suitable for high resistances. It is suitable for low resistances. But be clear, there's a general doubt. People asking that, sir, high resistance, how do you know? I mean, that is a question they will give. If I have 75 to 80 kilo ohm resistance, which method you follow? So can they give like that? Take this R, measure this. How can we measure this value? Take this R and measure this corresponding value. If he is saying like that, can we measure this value? No. Why? We don't know the range. If you don't know the range, is it low or medium or high? We don't. That is the reason why in the question, definitely they will and they should ask, they should give the question like, okay, 0 to 0.5 ohms range. So what is that? Low resistance. 100 ohms to 500 ohm. In the medium range, lower side. 75K to 85K, for example. Higher side in the medium range. Suppose 1 mega to 2 mega, like that. Automatically, that will be high risk. That's why they have to ask the question, means they will give the data. No need to worry. They will give the data. No need to worry. Clear? So therefore, they will give that, okay, take the so and so resistance and correspondingly find out the values. That's what the point. Clear? Okay. Sir, high resistances in medium range, low resistances in medium range. That's what the point. High resistance in medium range and low resistance in medium range. Clear? This is a simple idea we have taken in the yesterday's class. Right? After that, instrument transform anyway, lengthy numerical model we have taken. Okay. Now, let us take the first topic in this today's class. Let us start the topic now. That is substitution method. So what do you mean by substitution? Based on this, in your network theory, substitution method is also there. Substitution theorem is also there in your network theory. Same concept here and there, same concept. Those who are completed with the network theory, it is a revision. And those who are not done with the network theory, this is a starting topic, that will be the revision. What is substitution? Means before and after the replacement, before and after the replacement, the circuit status should be same only. If the circuit status is same, that is called as simply substitution method. What is that? Let us see now. So simply concentrate here. I'm taking one circuit. This is some voltage. Rheostat. Rheostat is always for varying purposes and to get a particular current. And here some ammeter. Okay. After that, here switch will be there. This switch has two positions. In one position, we are going to keep R. In other position, we are going to keep variable standard resistance. Variable standard resistance here. And this is the circuit arrangement, right? Very, very important here. Here, this is anyway unknown resistance or medium resistance to be measured. Unknown resistance R. Okay, this is position 1 and this is position 2. Position 1 and position 2. Okay, right. Now the question here is, concentrate guys. Sir, what is the procedure? First one, keep the switch in position 1. Keep the switch in position 1. Complete note I'm giving. Keep the switch in position 1. If the switch is kept in position 1, what will be connected in the circuit? Voltage source, rheostat, and ammeter along with the corresponding R. Along with the corresponding R will be available. Clear? So therefore, if you are keeping the switch in the position 1, V sub current will be flowing like this. The current will be flowing like this. R ammeter to the R like this. Okay, this is the current path. Sir, after keeping this switch in position 1, concentrate here. After keeping this switch in position 1, very, very important point here, vary the rheostat. Vary the rheostat until the ammeter shows any considerable value. Until the ammeter shows 1 ampere, 2 ampere, anything what you require, no problem. Anything. So therefore, let me take X ampere. Let me take X ampere. Okay. Then the point here is, sir, once the ammeter shows some current, if you are noting down, don't vary this rheostat. Stop varying. I'm coming again. First step, keep the switch in position 1. Vary the rheostat until the ammeter shows any considerable current, and the moment you are noting down that X amperes, stop varying that and noting X amperes. Okay. Sir, be clear. Sir, you have noted down the X amperes. Okay, well and good. Okay. Second case. What is the second case? Very, very important. Without changing this, without changing its position further, without changing this, all these three should be as it is. Whichever there in the first step, always as it is, we need to maintain. Now, the switch must be changed from position 1 to 2. Position 1 to 2. So, if the switch is changed from position 1 to 2, which will be connected? V, RH, A, and X will be connected, right? Okay. Before going to that, what is the value of X amperes in this first step? Supply voltage V. Current is flowing through RH plus meter resistance RN plus unknown resistance R. People are asking that, sir, X is known, V is known, RH is known, RM is known. We can get the R value. Okay, well and good. But suppose, if he has not given value of V, supply is given, but value we don't know, 20, 30, 40, we don't know. We don't know. For example, if that is the case, we cannot determine the R value. That's why what we are doing, after noting down this, change or move the switch position from 1 to 2. Move the switch position from 1 to 2. Then automatically, if the switch position is moved from 1 to 2, if the switch position is moved from 1 to 2, so what will be the concept here? Concentrate. Now the current is flowing from V, RH, A, and S. But be clear, these three are same in the first step as well as second step also. That's why after moving the switch to second position, we should not vary this further. Already we varied in the first step, keep it as it is. Don't vary. Now, sir, vary the standard resistance. Vary the standard resistance until the ammeter shows same current. Vary the standard resistance until the ammeter shows same current. So therefore, in the second step, what is that? X ampere, same current, same current. Okay, V by. So in the second step, V, same V which we maintained in the first step. Same RH we maintained in the first step. Same ammeter, same resistance we maintained in the first step. But in the second step, in the place of R, which is there here, S is into picture. Now, from these two equations, what is the result? From these two equations, what is the result? Come on, simply X and X is same, VV same, RH, RM, everything is same. So directly we can write which value here? Yes, therefore R is equal to standard resistance. But here many doubts are there. So standard distance already know. Standard distance already given, but which value? We don't know. Why? We are varying. That's why, be clear guys, we need to vary this until the ammeter shows same current which is maintained in the first step. The moment it is showing the same current, stop varying that. Automatically, that value corresponding to this X amperes, that value of resistance is equal to the unknown resistance R. So that's why simply R is equal to S, we can say. R is equal to S. But, sir, in the gate paper, do they ask the question in the same way? No. What is that question, sir? When we, question is like, suppose if R is placed in the first step, when the R is placed in the circuit, the ammeter shows 5 amperes. When the standard resistance is varied at 4.5 kilo ohms, same 5 amperes is given, 5 amperes is observed, then what is the value of R? Do they ask this question in the gate? No. In the question itself is answer is there. That's why, be clear, in the gate question, in the gate model or ESC model or competitive examination model, how the question will be given? How the question will be given, they will be twisting the corresponding thing. Why means simply in the numerical must be possible over there. That's why they will change it. But experimentally, what is it here? We need to get same current in both the steps. But in the first step, R is unknown, rheostat is varied, some value, and current value known. After that, don't vary this rheostat. Don't vary this rheostat. After that, vary the standard resistance until the ammeter shows same current. Vary the standard resistance until the ammeter shows same previous current. So therefore, at whatever the value of S, the ammeter shows same previous current. That itself is the unknown distance are very, very simple. This is called as substitution method in the laboratory experiment purpose. But numerically, how the question will be given, we are going to see that later. Is this topic clear, guys? Right. Rheostat will be varied in the first step. I told you, rheostat is varied in the first step. Second step, only standard resistance. Right. What is REM? Meter resistance. REM, meter resistance. That will be given in the data. So and so meter has so and so resistance. Right. Almost same as DC slide over X. Yeah, same thing. Yes. Any resistance we can find, even range will be there. Medium resistance, range will be there. Range will be there. Right. 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 Be clear, guys. Here limitations are there, but I told you operation is clear or not. Operation is clear or not. See, when people are asking that only I'm saying here, Sir, if we move the switch from position 1 to 2, ammeter reading will be changed. No, that is what? By varying this rheostat, sorry, by varying this standard resistance, we are bringing the same current. That is what this point. That's why this SC is variable, varied, and this current will be equal to the same previous current. That's what the point. But here limitation is there, no doubt. Limitation is there. So what is it? Limitation means suppose standard resistance is 0 to 5 kilo ohm is there, for example. You can vary from 0 to 5 kilo. Then automatically unknown resistance also 0 to 5 kilo ohm should be there. If it is 7 kilo, 8 kilo, whatever the resistance you keep, can you get that answer here? That's why limitation is there. That is no problem. For a given condition, for a given range only, is it working properly or not? Yes, it is working properly. That's not the actual point. Difference between the rheostat and variable resistance, both are same. Both are same. Both are same. This is the method used for measurement of medium, but according to this medium range, suppose this medium resistance range is 50K to 60K is there, for example. The standard resistance must be up to 60K compulsory. That is anyway limitation problem will be there, but for a given values, this is the best method. This is the best method automatically. So no need to worry. That's why operation only asked, is it clear or not? Limitations I'll give you, no need to worry. Right, very good, correct. Shirisha, correct. First step, rheostat. Second step, variable resistance. That is standard. Don't worry. I will give the note. No need to worry. No need to worry. So first step, what is that? Here. Place the switch in. Place the switch in, right? Position 1. Place the switch in position 1. Vary the rheostat RH. Vary the rheostat RH until a current, say X amperes. Right? Now, note down this value. Okay. Second step. Move the switch from position 1 to 2. Position 1 to 2. But be clear. Now, vary the variable standard resistance. Variable standard resistance. But be clear, without varying the other circuit elements. That's why in the first step we vary the rheostat. Second step we don't vary the rheostat. We vary the standard resistance only until the ammeter shows. Until the ammeter shows same previous current, that is X amperes. Same previous current, that is X amperes. Right. Because all I told you 10-20 times, if you want to message, kindly get out from the session. Right? What is it here? Rheostat and variable resistance already told you same, but still you are typing 1 time, 2 time, 5 times, 6 times. Don't type it. Don't, if that is the case, don't attend the class. Not only mine, any class. So kindly consider variable resistance and rheostat, both are same only. Same only, already told you, both are same, right? But I cannot say it is a rheostat, it is rheostat. You'll get confused. Sir, which is the first rheostat, which is the, that's why this is simply a rheostat variable resistor. It is standard resistance, varying facility is there. That's it. At least now, after this note, clear everyone? This is the total discussion regarding, what is it here? Medium resistance measurement by substitution method. But no doubt, limitation is there. What is the limitation? If the resistance is around 60K, 70K, 80K is there, Definitely it should have in the same range of wide range of facility. That is what general point. Clear? Right. Very simplest method. But once you see the numerical question, then you can understand what is that numerical question. Concentrate. In the bridges, if you take the corresponding question, we can come to know that. In a measurement of resistance by substitution method, right? In a measurement of resistance by substitution method, which method, guys? Substitution method. Okay, be clear, guys. A standard 0.5 mega in this question, standard resistance is not variable, fixed value is given. How do you proceed? As we can take standard 0.5 mega ohms resistor is used. Okay, the galvanometer has a resistance of 10 kilo. I used ammeter. He is using galvanometer, no problem. 1 meter. Okay, and he is giving that the galvanometer resistance is 10 kilo ohm. Okay, right, sir. So far I have taken ammeter. That's why I have taken ammeter. Deflection is x amperes. Ammeter deflection is x amperes, etc. We have taken. As he has taken galvanometer, he is giving the deflection in terms of divisions, because the pointer may be moving right side or left side. Only deflection. Divisions means the pointer of a galvanometer moving by 41 divisions, moving by 51 divisions, like that they have given. But that too, with a standard resistor, when we keep the standard resistor, the galvanometer deflection is 41 divisions. Galvanometer deflection is 41 divisions. With unknown resistors, 51 divisions. Find the unknown resistance. How? Concentrate. First, let me draw the diagram. Sir, voltage source is there. In this question, rheostat he has not commented, so don't take it. And he has taken galvanometer. This is V for having the current flow. Galvanometer. What is the resistance? 10 kilo ohm. After that, concentrate. First step, which one? Standard. He has twisted the process. Simply, this is the switch. First position. What is this? S is equal to 0.5 mega ohm. Okay. Step 2, which one? That is unknown resistance R. Unknown resistance R. Okay. After that, this is the circuit. Now tell me, in the given question, do we have any variable parameter? No, nothing is variable. If nothing is variable, do we have any chance of getting same current in both the cases? Definitely no. That's why he has given that when the standard resistance is placed, galvanometer shows how many here? 41 divisions. Very simple, yeah. First of all, sir, more current to flow. Definitely more deflection will be there. Yes, current is more force will be there, more deflection. So therefore, what we can say now? Therefore, deflection is proportional to current. Deflection is proportional to current. More current, more deflection. Less current, less deflection. Okay, right. Now, concentrate here. So first step, I'm writing the first step. Sir, I is equal to, what is the formula? V by Rg plus S. Rg plus S. First step. Second step, what is that? Let me take I1 for example. Second step, I2. Sir, why? He has not given same current flow, but operation says that same current. But in the competitive examination, same current will not be given. If same current is given, answer is in the question only. That's why they will give the different currents. What is I2? V by same Rg plus unknown resistance R. Okay, but sir, current is not given, but current and deflection both are proportional. That's why what we can write now? Simply, therefore, deflection 1 proportional to V by Rg plus S. Deflection 2 proportional to V by Rg plus R. Therefore, what we can say now? Here, deflection. What is deflection 1? 41 divisions. Deflection 1, 41 divisions. 41 proportional to V by, what is Rg? 10 kilo ohm plus S 0.5 mega ohm. Okay. Now here, sir, 51 divisions are there proportional to same voltage, same galvanometer resistance, but R is unknown. This is equation 1. This is equation 2. What we can write from equations 1 and 2? Kindly proceed and tell me the value of R. Kindly proceed and tell me the value of R. Right. Many people give the answer. Correct. Come on. Yes. What's the answer here? R will be 0.4 mega ohms. Right? Suppose in the same question, I'm taking the standard experimental procedure. What is that? So in both the cases, same current should be there. Kindly concentrate. This is the question, but concept I'm giving. Same current, 41, 41, for example. Then 41, 41 cancel. Sorry, 41, 41 cancel. V cancel. Then, so V cancel. 10K, 10K cancel. R equal to 0.5 mega means that implies that is given in the question directly. That implies given the question directly, but in the gate paper, no need to. That is the reason why we need to concentrate on this one. That's why if that is given, if two currents are given same, no need to have the calculation. Yes, that's what. Right. Preeti Kazia. No need of calculation for this problem, no sir. Why? Why Preeti? Why no need to calculate? Okay, logic. Okay. Shortcut. I'll give you. You can get it. No problem. Without that, we can answer also. How? I'll give you. But I need to explain the procedure first. Yeah. Right. Very good. Sir, what is that? Be clear. Very good thought. Sir, in this question, what is the logic? Current is less. Current is more. So current is more means resistance is less than which one? 0.5. So 0.5, 0.7 points. In this question, directly you can answer. But if the option is given like 0.35 also, 0.45 also, then confusion will be there. That's why stand on the procedure first. After that, you can guide directly answer. Very good. Akash and very good. Right. Yes, correct. But procedure, suppose if I give that 0.35, then problem will be there. But in this question, yes, true. Yes, less than 0.5. Directly you can answer. Very good. In that way, you have to think. Clear, guys? So in this way, the competitive exam questions, GATE or ESC questions will be there. Right. Correct. Clear? Right. Now the very important, very popular method is, that is third method, that is Wheatstone bridge method. Wheatstone bridge method. Right. Concentrate here. Electrical people, as far as my subject considered, this is completely new to you. But instrumentation people, in the transducer part, so many times you have taken the bridges. No, this will be just revision to you. But electrical people, this is the first time for you people. Kindly concentrate. What is it? So what is Wheatstone bridge? All I told you, what is the bridge shape? I give the same thing. Here, the bridge will be like this. In the yesterday's introduction, I gave you. Okay. Here, between these two, supply, it is a DC bridge. No, resistance means DC supply. Okay. Between these two, one resistance. Like this. Okay. So this is P, Q, R, S, and here the galvanometer. This is called as bridge. Okay. But sir, in this, internal contact drops are not being taken. Is it okay or not? Is it okay or not? Internal contact drops are not being taken. Is it okay or not? Yes, it is okay. Why? It is medium resistance. If it is a medium resistance, no need to worry. No need to worry. Because in the yesterday's topic, I told you that was a low resistance. That was a low resistance. So that's why, what is it? Contact drops are to be taken. Yes, Kelvin's double bridge also maintain the same thing. No need to worry. But this is medium. No, yes, contact drops can be neglected, no need to worry. Contact drops can be neglected, no need to worry. Clear? Right. Now, what is the procedure? Sir, this is A, B, C, D terminals I'm taking. Assume that R is unknown. Assume that R is unknown. Okay. Suppose P is variable, Q is, suppose I'm taking P and Q are variable. Generally, in the KDV also I told you, yes, P, Q are variable. Here also same thing. For explanation purpose, I'm taking P and Q variable. Come on, guys. What is our unknown? What is our unknown here? R is our unknown. But in this bridges, there is no device like pointer is moving, showing the 20 ohm, showing the 30 ohm, not like that. In this Wheatstone, what is there? Bridge means itself is galvanometer approach. Galvanometer approach. So therefore, galvanometer is for which one? Yeah, zero current condition. That is called as balancing condition. We say. So what is it? Let us see now. Very, very simple. Vary the P and Q until the galvanometer shows zero. What is it? Until the galvanometer shows zero. Sir, if the galvanometer shows zero, what does it mean? Potential C, potential D. Potential C and potential D both will be equal. So therefore, VC is equal to VD. VC is equal to VD. Okay, then. Sir, what is VC? What is VC? VC is voltage across Q. VD is voltage across S. So therefore, VC means voltage across Q. VD means voltage across S. This is what the condition called as balancing condition. This is called as balancing condition. Clear? Right. Now, the question here is, sir, V is equal to VD, but after this, sir, IG is equal to 0. Yes, we can open, sir, because current path is not there. Open circuit. That's why I'm modifying the diagram for more clarity purpose. Like this. Here, see in the network theory, those who are completed or not completed, only one and only one technique here. Always don't fight with the given circuit as it is. No, you need to work with modified diagram. Then you can save the time. You can get the answer very simply. Okay, this is P, Q, R, S. Okay, sir, this is C, D, A, B. So VC means voltage across Q. With respect to, what is it? Written path. VD means voltage, that only I've written. Sir, across these two, voltage is E. Okay? Across these two, voltage is E. Is that no? So therefore, automatically, we can apply the voltage division law. We can apply the voltage division law. Sir, what is that? What is that? Be clear. Sir, I'm taking VC is equal to VD, VQ is equal to VS. But generally, recently also from the deep plan also, one doubt, right? One doubt arises. I'll tell you what is the doubt. VQ equal to VS. Sir, what is the voltage across Q? E into Q by E into Q by P plus Q. E into Q by P plus Q. E into, what is that? Here, S by R plus S. S by R plus S. So automatically E and E cancel it. Okay. Cross multiply. Sir, Q into R plus Q into S. P into S plus Q into S. QS, QS cancel. What is the remaining part now? Therefore, QR is equal to PS. Consider guys, this is also treated as balancing condition. This is also treated as balancing condition only. This is also called as balancing condition. Okay, right. Now the question is, sir, from this unknown value, R is equal to P by Q into S. So we have calculated. That's why in the bridges we don't have in the bridge circuit we don't have the device in that the ammeter, the corresponding resistance meter is pointer is moving showing 100 ohm, 1000 ohm, 1k, 2k, etc. No, mathematically when the galvanometer should. That's why the bridges question is there means definitely first our task is to get the balancing condition. From that, based on the balancing condition mathematics, we are going to complete this entire, we are going to solve this entire thing. That's why R value is calculated. Bridges procedure is mathematical based only, calculation based only. So no need to worry. R equal to P by Q into S. Okay, right. Sir, concentrate, concentrate. People, what is general doubt? You know, this is general doubt for electrical people. Sir, why you have taken, what is it? VQ only. Sir, VC means why only VQ? VD means why only VS? Sir, VC means why not VP? VD means why not VR? Okay, no problem. Means VC, VP I'm taking here. VC is equal to VD. No, I'm taking VP is equal to VR. Both will be same only. Sir, why? You know, sir, if these two voltages are equal, automatically these two voltages should be equal. Sir, how? This is 10 volt. Okay. Here 4 volt is there. Here also 4 volt is there. Okay. But out of the 10, 4 is there here. Automatically 6 volt, 6 volt here. People are asking, sir, you are equating these two. Can we equate these two or not? Undoubtedly, without any second thought, you can equate. You can equate. No problem. I'm proving that also. Sir, what is that? VP. What is VP? E into P by P plus Q. E into R by R plus S. E is cancelled. Okay. P into R plus P into S. P into R, right? Plus Q into R. Okay. Now, which is cancelled now? PR will be cancelled. So therefore, PS is equal to QR. See that. Same condition. That's why no need to worry. That's why you need to have the basics of, we need to have the basics of electrical circuits compulsory. Basics of electrical circuits compulsory. Now, third question arised. Sir, why not P equal to S? Come on here. How can you take it? Here, this is the potential. If this is the potential, with respect to one node will be there. Which node? VC to B. Either written path or the forward path. But once by taking what is VP, YVS, come on, those two are at different potentials, different circuit arrangement. Definitely no. That's why stand here either with respect to this node or with respect to this node. If you're taking with respect to B, stand here with respect to B only. Otherwise, with respect to A, with respect to A only. That's what the electrical basics. Bhavana, clear? So this is the way of taking the point. From that common point, you have to take either lower side or higher side. Be clear with the terminology. Okay. Now tell me either this side or this side, no problem. Here also, sir, R is equal to P by Q into S. Okay, right. So from now onwards, whether the given bridge is balanced or not, whether the given bridge is balanced or not, how to verify, how to check it, be clear. This is very, very, very important point. Why I have given this entire mathematics from this one formula, from that formula only we are going to take entire things. What is that? Here, QR, PS, PS equal to Q. What is that? Check it here. QR opposite, PS opposite. If opposite branches are multiplied and the value is equal on both the sides, automatically we can say that yes, the bridge is under balanced condition. The bridge is under balanced condition automatically. Clear? This is what the corresponding topic related to Wheatstone bridge basic point. Right. See, galvanometer IG0, I have taken open circuit. Yes, same answer will be there. No need to worry. Our topic is this one. So kindly concentrate. Okay. After that, sir, in this what are the things we need to study further? We need to study further, we need to talk about bridge sensitivity. We need to talk about bridge sensitivity. Sir, what is a bridge sensitivity? For that purpose, a separate bridge I'm taking now. Sensitivity I'm taking. Right. Now be clear, guys. Sir, here I'm taking 4 branches like this. P, Q, R, S like this. This is P, Q, R, S. Kindly concentrate in this figure, which is unknown. I'm not giving anything. May be unknown in the question. Anything may be unknown. Anyone may be unknown. Okay, right, sir. In this, galvanometer is being taken. Okay, right, sir. I'm changing only one, because in the numerical question, only one resistance will be changed. So based on the topic I'm taking, okay, I'm changing the R value from where to where? R to R plus delta R, for example. R plus delta R, for example. Automatically, if you're changing from R to R plus delta R, definitely in the galvanometer, deflection will be changed or deflection will be same. Deflection will be changed. Why? As you keep on changing any branch resistance, galvanometer pointer will be keep on getting changed. Yes or no? That's why the galvanometer deflection depends on the resistance change. Depends on the resistance change. In this circuit, I'm taking R, but don't question, like, don't get the thought like, sir, R is unknown. No. In this, whichever is unknown, we don't know. Simply 4 branches are there because we are finding the sensitivity. So concentrate. In the sensitivity topic, I'm dividing this into 2. One is meter sensitivity. One is meter sensitivity. And second one is bridge sensitivity. Meter sensitivity. And the second one is bridge sensitivity. Okay, what is that, sir? This meter can be studied either in terms of current concept or in terms of voltage concept also. Why, sir? Galvanometer current I'm talking means current sensitivity. Galvanometer voltage I'm taking, that is voltage sensitivity. Simply C and it. That's why in the meter again I'm defining with respect to voltage, I'm defining with respect to current. Both are meter sensitivity. Which one? Galvanometer sensitivity only, but in terms of current, in terms of voltage I'm taking. Okay, next, sensitivity of the bridge means always SB only. And everyone knows that what is sensitivity definition? Sensitivity formula: change in output by change in input. But be clear which output we are observing from the bridge. Come on, guys. Which output we are observing from the bridge, that you have to take. That's why concentrate. First of all, everyone, kindly don't get deviated. Point by point I'm coming. Sir, in this entire circuit, which parameter you are varying, that is called as input change we are providing. Which one? Change in resistance. So therefore, what is that? In the bridge, change in resistance. Change in resistance. Okay, sir, with this change in resistance, which is happening first? With this change in resistance, what happens here? The current flow in the circuit will be changed. Voltage drops will be changed. Yes or no? Therefore, assume that if you keep on changing that, VC will be changed, VD will be changed. So therefore, with respect to VC and VD change, current will be changed. With the current change, galvanometer pointer will be changed. So therefore, ultimately, from the bridge, which output change we are observing here? Change in deflection. That's why everywhere delta theta. Delta theta. But sir, if I'm talking about the entire bridge, in the entire bridge, which is the input change given by us? Resistance. Okay, resistance. Which is the output change observed by us from the bridge? This only. But people are saying that, sir, R. Are you observing the value of R? No, you are not observing the value of unknown R. You are observing the value of galvanometer pointer only. After that, mathematically calculate. That is different. But observation is only point of deflection theta. Okay, next. So if I'm talking about only galvanometer, only in the galvanometer also, which change we are observing? Delta theta, delta theta, delta theta. But sir, voltage, no. So this delta theta is because of which voltage change? C and D. So we see difference of VD. I can write simply delta theta minus, what is it? V naught. I can write here simply V naught, how much change is there, etc. Or delta V naught. Okay, next. Sir, if I want to write in terms of current, if I want to write in terms of current, as the current flow either top to bottom or bottom to top is varied, automatically galvanometer pointer will be changing. No, yes, simply delta Ig. This is the total topic related to sensitivity of the meter in terms of voltage, in terms of current, and sensitivity of the bridge also. Sensitivity of the bridge also. Clear? Clear, guys? So therefore, what's the point now? In this entire thing, whatever the basics I told you in the error analysis topic, sensitivity, same thing. I told you clearly, input means not input power, output means not output power. What I told you, whatever the change we are making, that is input change. Whatever the change we are observing, that is output change. That depends on condition to condition, requirement to requirement. That's why this was the point. But further simplification, sir, delta theta, okay. But sir, writing purpose statement, change in resistance only we write. But is it delta R we have to write, or delta R by R we have to write? Which is correct? According to the concept, according to the concept. Now tell me, delta R we have to write, or delta R by R we have to write? Which is correct among these two? Now asking the question, kindly respond. Right. Okay, few people delta R, few people delta R by R. So kindly don't stand with the statement. Statement change in only, but which change in? That's what I'm asking. Okay, equally given. Few people are giving delta R, few people are giving delta R by R. Okay. In order to answer, I'm giving the example. You need to answer after taking this example. Concentrate, guys. Sir, one bridge is there, other bridge is there. Concentrate, guys. Sir, this is 5, 4 is a 20, 10, 2 is a 20. Sir, 5 4 is a 20, 10 2 is a 20. Galvanometer shows 0. Okay, Ig equal to 0. Okay, happy. Means bridge is under balancing condition. Okay, sir, here I'm taking 100, 100, 100 into 100. What is that? 10,000. Okay, here I'm taking 1000 into 10, 10,000. Bridge is still balanced. Okay, two bridges are balanced. Two bridges are balanced. Concentrate here. Two bridges are balanced. The pointer is showing which value? 0 value. The pointer is showing 0 value. Okay, galvanometer shows 0. This is balancing condition. Okay, happy, happy. But be clear, guys. Be clear, sir. After this, what I'm doing, concentrate. In this branch, I'm changing this resistance by 1, means I'm making 11. Okay, sir, same right side branch only. I'm changing this by 1. I'm getting 1001. So now tell me, in both the cases, whatever the galvanometer deflection is there, whatever the galvanometer deflection is there, that deflection will be same or different. Now answer again, one more question. In both the cases, earlier it was showing 0. Now I changed it by 1 ohm. I changed it by 1 ohm only. Now tell me, in both the cases, the galvanometer deflection will be same or different. Means same sensitivity, different sensitivity. Come on. Right. Very good. Major people give the different only. Why means, sir, here 11 into 2, 22, 5 into 4, 11 into 2, 22, and 5 into 4 not equal. Here 1001 into 10, 100 into 100, both are not equal. Here also 1001 into 10 is not equal to 100 into 100. But my question is, where the difference is more? Where the difference is more? Here difference is almost zero, but difference is considerably two. Difference is clear. That's why now tell me, in this case, whatever the deflection is there, that is not same. Even though change in resistance provided is one, change in resistance provided is one only, but one concentrate here. 1 out of 10 means you have provided the 10% change resistance. Here 1 out of 1000 means you have provided 0.1% of change in resistance. Automatically, what is that? 10% of this, 0.1% of this. Can we get the same answer here? Definitely no. That's why in both the cases, from 0 to point of deflection, if you compare, same deflection will not be there. If same deflection not there, can we say same sensitivity? Definitely. That is the reason why, for writing purpose, what is it we write here? Sensitivity. What is it? Delta theta by change in resistance only. But we should write delta R by R. Why? Already told you the complete proof. That's why here 1 and 1. So both cases 1, 1, same change. So answer is no. 1 from the 10, 10%. 1 from the 1000, after all 0.1%. Do you have same answer here? Definitely no. That's why sensitivity not only depends on change in resistance, but also depends on from which value you are changing, out of which value you are changing. That is what very, 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 very important point. Clear, guys? If you understand this basic point, my complete next topic will be very, very simple. Can you respond? Why delta R by R? Clear or not? Respond kindly. But of course, 95% of people say that answer that different only. Yes, correct. With proof only I'm asking. Very good, very good, very good. Okay. Right. Now I'm going to take the corresponding mathematics and all. Right. Concentrate here, sir. In this, we are going to find out bridge sensitivity formula. Yes, as it is. But here, sir, small modification I'm giving. Sir, this is delta V naught. You can take delta theta by E also. You can take delta V naught or simply E. So V naught or E, any letter, no problem. No problem, no problem at all. So from this, and from this entire thing, what we can do means, consider guys, sir, therefore, bridge sensitivity SB is equal to, bridge sensitivity SB equal to, from this delta theta is equal to E into SV. So in the place of this, E into SV by delta R by R. Means one question may be there. Find the bridge sensitivity. E, change in voltage they will give. Sensitivity of the bridge they will give. That's altimeter they will give. And delta base. Sometimes like this also question may be there. Question may be there. Clear? Any confusion? Kindly let me know. Right. Now let us proceed with the same figure. Now we are going to find out the corresponding bridge sensitivity. Everyone consider this is complete mathematics, but in this concept is there. After that, we'll get the complete conclusion. Based on this, gate 1 mark question is there, 2 marks question. ESA also, yes, objective question chance is there. What is that? Here, I'm taking the bridge again for clarity purpose. See, in this chapter, so many times we need to draw the bridge. Kindly habituate. Supply voltage E, galvanometer, right? P, Q, R plus delta R, and yes, R plus delta R, and yes. Sir, if it is R, already we know that is balancing condition, for example. Otherwise, I'm saying like this, sir. Yes, assume that P, see, under this condition, bridge is balanced. That is P into S is equal to R into Q. So therefore, voltage across the galvanometer is 0. Already we have taken. Yes or no? Under this, we are treating like this is the balancing condition. What is it? Galvanometer value pointer is showing exactly 0. Now, if the resistance is changed, if the resistance is changed, this is P as it is, Q as it is. This becomes R plus delta RS and E and galvanometer. Obviously, the galvanometer will not show 0. Yes or no? The galvanometer will not show 0 at all. Galvanometer will not show 0 at all. Right. See, already told you, we are writing the gate 2022 here. We are not writing the gate 2021. Already before the starting subject only, I told you, general weightage is 3 to 4 marks. Sometimes 3 marks, sometimes 4, sometimes 6, sometimes 1 mark also. But as the last year paper is only 1 mark question, next year also 1 mark, we may not be expecting. That's why we need to follow compulsory. If you're not interested, I cannot say anything, but all the questions, all the concepts must be definitely taken. Right? Kindly, earlier paper is only for reference, but that will be as it is. No, earlier 6 marks was there, 4 marks was there, 3 marks also was there from this subject. Now, last year only 1 mark, but 2022, 5-6 marks may be there. We cannot. That's why everything must be studied. We don't know from which corner we need to study. We need to focus on it. We don't know. That's why we need to focus all. So kindly concentrate. And one student asked that instrument transformer also. So many years there was no question, but still we need to study because in the 2022 chance may be there. That's what the point. Okay, right, concentrate guys. Complete mathematics I'm taking now. Sir, what is the voltage across the galvanometer? VC difference of VD. Okay, sir, the bridge is not balanced definitely. Why? P into S is not equal to Q into R plus delta R. Therefore, bridge is not balanced. Already we explained this. Okay, right now, sir, what is that? V naught. I'm taking here. This is I'm writing as VG. Nothing but 1 second. 1 second. I'm writing like first case it is. So V naught 1 is equal to 0. First case. Okay. This one V naught 1. In the second case, I'm taking V naught 2. Definitely not balanced means V naught 2 is not 0. But how much we don't know. But not 0. Why? Bridge is not balanced. Am I clear? Yes or no? So therefore, sir, what is V naught 2? V naught 2 is nothing but VC minus VD or VD minus VC. Anything you can take, no need to worry. Both will give the same result. No need to worry at all. No need to worry at all. Clear? Okay, now let us verify. Sir, what is VC? I'm taking Q. What is that? VQ minus VD means VS. Like this I'm taking. After going home, you practice with this. You will get the same answer. No need to worry. Sir, what is VQ? Voltage across this means E into Q by P plus Q minus E into S by which one? R plus delta R plus S. Okay, it is not equal to 0 here. Not equal to 0. Definitely, yes, both are not equal to 0 only. No need to keep every time, but for clarity purpose, I'm keeping it one step. Okay, now, sir, E I'm taking as common. What we can write? Q by P plus Q minus S by R plus delta R plus S. Okay, sir, if you go back in this entire analysis sir, Q by P plus Q, what we can write? S by R plus S we can write. Q by P plus Q, we can write S by R plus S, no problem. So therefore, what I'm writing now, in the place of Q by P plus Q, I'm writing like E into S by R plus S minus E common. What is it? S by this entire value. S by R plus delta R plus S means I'm bringing everything into RS combination to have the simplification because delta R is R notation only. Yes. Now let us have the mathematics, simple mathematics only. E into, sorry, S into R plus S into delta R plus S square minus R into S minus S square by R plus S. Here I'm writing like this, sir, R plus S plus delta R. Okay, total value. Sir, if you simplify this, S square, RS cancel. What is the remaining part? E into S into delta R by. Sir, R plus S, Sir, compared to R plus S, delta R, we can neglect or not. Yes, delta R is here 0.1, 0.2, 0.3, very small. Delta itself is small. Compared to R plus S, we can neglect it. That's why R plus S. Therefore, R plus S whole square. Since I'm writing delta R is far less than R plus S. So I'm writing yes, this one. If anyone doubt is there, kindly concentrate. I'm repeating. Compared to R plus S, compared to R plus S, delta R, compared to R plus S, delta R can be neglected. Not only S, compared to R plus S, neglected. Now, after that, simply expand this. What will be there? E into, this is which value here? Don't forget, V naught 2. Okay, this is V naught 2. V naught 2 equal to E into V naught 2 equal to E into which value? S into delta R. S into delta R by R plus S whole square. Simply expand it. R square plus S square plus 2RS. R plus S square plus 2RS. Okay. Now I'm bringing this R to the new denominator side. If I'm bringing R to the denominator side, what will be there here? R square by etc. So therefore, I'm here. What I'm doing, I'm dividing and multiplying with. I'm dividing and multiplying with R. I'm dividing and multiplying with R notation. How do we take it? And all? If you simplify this entire thing, we are going to get one terminology that is V naught 2. That is V naught 2. So after this V naught 2, what is the corresponding change in voltage? Means I'm leaving this like this simply. Sir, this is V naught 2. Concentrate. Therefore, change in voltage E is equal to V naught is equal to V naught 2 minus V naught 1. What is V naught 2? This one. V naught 1 is already we have taken now. V naught 1 earlier balanced condition 0 only. Yes. So therefore V naught 2 only. Right? Right. See, delta R is user defined, but in the numerical point of view, compared to R plus SR, we are neglecting, but I'm not neglecting this. People are asking that, sir, why don't you neglect in the numerator? In the numerator, it is in the multiplication mode. In the numerator, it is in the multiplication mode. Or how can you neglect multiplication mode here? So 1000 into 10. Suppose I need to give 1000 into 10 rupees. I need to give. Sir, compared to 1000, neglect this 10. I will give 1000 rupees. Do you accept it here? No way. Suppose 1000 plus 10. Yes, compared to 1000, 10 can be neglected. But question is very good. Sir, delta R is user defined. That's why I'm not neglecting everywhere. Wherever I can feel like very small compared to the larger value. Yes, but here I'm maintaining. I'm not at all neglecting the total delta R value. No, wherever it is possible, conceptually, mathematically, yes, we are neglecting. Clear? Right. People are asking, sir, how you have done voltage division law? Come on here. What is voltage division law? These two are these two are coming across the supply voltage. That's why I told you, finally, it is not equal to 0. If it is not equal to 0, yes, we can apply the voltage division, a simple circuit theory. If I say equal to 0, then that is the wrong point. That is the wrong point. So be clear, guys. Be clear. After this, sir, E equal to V naught 2 only. Therefore, E is equal to E into S delta R by R square plus S square plus 2RS. Clear? Right? Clear, guys? Right. From this, I'm taking RS common in the denominator. I'm taking RS common in the denominator. Therefore, E is equal to S into delta R by, I'm taking R and S denominator. What is that? Here, 1 plus, this I'm writing, 1 plus R square by RS. R square by RS plus S square by RS. Okay. And what is that? Here, 1 by RS. I'm taking RS. Sir, S and S will be cancelled. So therefore I can write delta R by R by 1 plus R by S plus S by R. This is the value of E. Clear, guys? One second. Sorry. Yeah, it is 2. 1 second. 2 is there. No, correct. Correct. 1 second. It is 2 only. Okay. Now, therefore, sensitivity of the bridge is equal to what I have written here. Sensitivity of the bridge here. In this case, I explain E into SV by delta R by R. We can write, or this, both are same. E into SV by this value. E into SV by delta R by R. E into SV by delta R by R. This is, what is that? Sensitivity. Sir, what is E? What is E? Sir, delta R by R, delta R will be cancelled. Listen, now how to proceed? If you substitute E value over here, how do you proceed that? That's what the main point here. What is that? Sir, E I'm substituting here. Delta R by R. Delta R by R into, or by, which one? 2 plus R by S plus S by R by, right? I'm writing every parameter. E into by delta R by R. So therefore, automatically it will be cancelled. So therefore, bridge sensitivity is equal to E, sorry, yes. Okay. Now, how to proceed this entire thing? What is that value? Here, SV, E value are substituting like this and substitute over here. If you proceed that, what we are getting? Kindly tell me the final value. Can you tell me the final value? Are you concentrating, guys? Very good, very good. Yes. Amrit, yes, sorry, Amit Vikram, Kangam, and Alan Matthew, Gagan. Very nice, very nice, very nice. Correct. You are observing properly. Sir, in this entire thing, E is there, capital E, supply voltage. Therefore, E into SV will be there. So kindly focus. You are not focusing on this, but you are asking, sir, why delta R is neglected? Delta R is very small value. In the mathematical part, you are neglecting. In the instrument transformers in the yesterday's class also, I told you, I naught square, very small value, sine square delta plus alpha, you can add it. That's what the point. So therefore, sensitivity of the bridge is equal to, what is the value here? E into SV by 2 plus R by S plus S by R. This is the sensitivity of the bridge, complete mathematics. But my question is, sir, concentrate, sir, how do we get or when do we get maximum sensitivity? Condition for, concentrate here, condition for maximum sensitivity of the bridge. Maximum sensitivity of the bridge. Come on, guys. By looking at this formula, mathematicians tell me at what condition the sensitivity will be maximum. Very nice, very nice. Yeah, respond like this. Good. Other people? Very nice, very nice. Yes, correct. So therefore, what we can write? That is S is equal to R. Right? How can you say S equal to R? How can, I'm not taking, I'm assuming like if S is equal to R, if S is equal to R, what is that? Sensitivity of the bridge will become maximum. What is it? E into SV by 2 plus 1 plus 1. What is it here? 1 by 4 E into SV. This is what the maximum bridge sensitivity. Actually speaking, objective paper, maximum bridge sensitivity. Remember, 1 by 4 supply voltage times of SV. But in this entire mathematics, here, this is playing the major role. Whatever the delta R you are neglecting, no? Yes, here, delta R very, very important. That is the reason why I am giving the corresponding technicality-based mathematics in the classroom. Right. Shivanath Ganesh, if denominator equal to 0, that is infinite. I'm asking about what is it here? Maximum. That is maximum. So therefore, denominator should be minimum. So minimum is possible when S equal to 1. Yes, sir. S is equal to R value. So automatically, yes, denominator will be minimum, numerator will be maximum. Oh, that's why simply ratio will be maximum. Not numerator, ratio will be maximum. Right? Kindly don't say, sir, this is 0. If that is 0, that is infinite sensitivity. That is ideal case, not practical. This is a total discussion regarding mathematics of entire bridge topic. Clear? Why I have taken all these basics? You need to understand the what is it? Voltage division law, mathematical equations. You must be able to understand. For that purpose, I have taken all these questions, all these numericals. Otherwise, simply, yeah, proceed here like this, simply answer. But I have given, kindly practice this again. And IN people, those who are on the line, IN people, these type of bridges, so many times we have taken, so many times you have taken in the transducers topic, so many places. That too, 1 by 4, ESV, it is called as quarter bridge in that subject. So same thing. But I'm requesting everyone here, don't mind. I'm requesting everyone, kindly don't miss the classes. Don't miss the classes. You may be thinking that I will be listening the class after the session because recorded class. Okay, if you listen, okay, happy. But if you are unable to listen, that's why you're missing. That's why kindly don't miss. In the yesterday's class, Sunday class, 2 to 8:30, few people miss the class. Means I by seeing the number I'm saying. So the kindly don't miss the classes kindly. Right? If you miss the class, some topic will be missing. Of course, you can watch the recorded video, but kindly don't try to miss the class. I'm requesting everyone so that the subject will be in the continuation. That's what I can see few names. That's what. Right. Yes, Sri Vidya, it is balancing condition or unbalanced condition means we are taking the same notation under normal condition. This is the ratio and I'm using that. Finally, concentrate, you're missing something. Yes, 2-3 people are asking the same thing. No problem. Sir, here, what is that? Q by P plus Q is there in the balancing condition that is equal to which value? S by R plus S. So how can we use this in the corresponding unbalanced condition? Means be clear, sir, even after removing this with S plus S plus R, yes, sir, S by R plus S, it is still not equal to 0 only. No problem at all. So that's why it is balanced and unbalanced not matter. Earlier, initial values we need to substitute or not? Yes, I have substituted the initial values. I have substituted the initial values. Okay. Okay. See, I don't mind I missed one class, but now feeling bad. Sorry, Aishwarya, very good, very good. You should feel bad actually. If you miss the class, you should feel bad. Then you can understand that how much pain it will be. Okay, okay. See, very good. You are obediently responding, but very good. I'm requesting if under emergency case, okay, but just like that, don't miss it. Okay, I had interview. Okay, okay, no problem. Okay, no problem, no problem. See, even after missing the class, if you are able to watch the entire video and getting the subject, okay, happy. But other people, tomorrow means by the time, what is that? Course will be completed. Course will be completed. Yes, yes. Few names I can identify. That's why I'm saying this. Right, right. Okay, yeah. Few people are having exams or it's something is there. But kindly try to manage. Even you are missing, I don't mind. But you need to go to the corresponding recorded videos because by the experience I'm saying, last year students, many people told that, sir, I have not watched the recorded videos, etc. That's the problem. Very good, very good. Ah, okay, right. Very good, very good. Very nice, Varsha. Very nice. Okay, now come back. Sir, this is the total discussion related to Wheatstone Bridge, everything. But one question will be definitely there. Already one student asked this question. One second. One second. Already one student asked this question, sir. In the unbalancing condition, as the two branch resistance are not equal, as the two branch resistance are bridge is not balanced, how can you apply the voltage division law? Yes, I will come to that. That is the lack of network theory basics. I can say clearly. No need to worry. I will explain many of the things. No need to worry. Yeah, Dinesh. Yes, yes, very good. Yeah, still okay, okay. If net problem is there or any emergency case is there, okay, no problem. I don't mind, but you need to watch it. And few people are saying that sir, recorded class video is not effective. Definitely will not be effective that much. That is only for revision purpose. Suppose you are watching the you are going through the notes. Small doubt is there. So what was the statement given by the faculty? Okay, go to that video. Just forward, forward, forward. Okay, at that point that is for that purpose only. We kept that recorded video version. Okay, right. Now, this is $1,000,000 question here. Many people are asking the same question that many people are asking the same question that here. Generally, two questions are very right. See, very important point. Two questions are there, right? Now, first of all, sir, here, sir, it is unbalanced. If it is unbalanced, current will be flowing through this. Current will be flowing through this. If the current is flowing through this, how can you say these two are in series? I did not say series, but good question. So how can you apply the voltage division law? Means that is what the network theory concept that is, sir, I'm taking the what is it? These two are in series, I'm taking indirectly. These two are also in series, I'm taking indirectly, but immediately I'm providing equal to not zero means okay, equal to not zero is there means there is no two branches, this and this, these two, these not series, something is flowing. In order to have the more clarity, I'm giving the network theory model like this 5 ohm, 6 ohm, 9 ohm, 10 ohm. Suppose if the question is given like find out the voltage between these 2 points, but resistance value is not given. How do you do it? This resistance value is not given, but you need to find out voltage drop across these two. How do you find out? Same procedure. What is that? Find out the potential at this point. Find out the potential at this point. Yes or no? And by finding these two potentials, simply difference between these two. How do you find out those two potentials means? Opening this. But we are opening mathematically, not practically. After that, again, we are proving that this potential, not same. So current is flowing like that. We are proving. Kindly, I'm requesting everyone, those who have completed, they have to be perfect in the network theory because that is our life. That is our life. That is our life compulsory. So no, those who are not complete network theory, you can listen later. But those who completed, revise compulsory. Right. Yes. Yes. Vaishnavi. Yes. I'm coming to that only. Second question. Sir, if I take, people are saying that, sir, if I take VD minus VS, if I take VC minus VD, I explain. Sir, if I take VD minus VC, like that, if you're taking the reverse notation, no need to worry. Yeah? Finally, you will be getting minus sign here. But our topic is magnitude only. So no need to worry. You can neglect the negative sign. I already told you, negative sign is there in this type of thing. Means instead of top to bottom, we are taking bottom to top. Instead of bottom to top, we are taking top to bottom. That's it. That is what the actual point. So that's why kindly, if negative sign comes over here, no need to worry. Actually speaking, I can write like this, but no need to like this. Actually, only magnitude only. Only magnitude like this. So no problem at all. That's why even though you get negative sign, don't get tensed. Don't get tensed. Yes, very nice, very nice. But one student told that, sir, apply the delta to star transformation, but be clear, this value is not given. No question of delta to star at all. Clear? Right. On this Wheatstone bridge topic, we are going to solve as many as possible questions. Then you can get one by one clearly. Okay. Now, many people ask this question in the error analysis chapter. In the error analysis chapter, one question was there, bridge question. Many people may say like, sir, answer this question, answer this question, answer this question, like that. Don't worry, yeah? Everything will be covered, but time has to come. At that time, I will cover every question. No need to worry. Right? That question I'm solving now. One second. No one should try kindly. I will do this. I will do this. Then you can get more clarity. This is the first question. No, I will do it. For other questions, I'll give the time to have the practice and time to give the corresponding solution and all. I will give it. Okay, right, sir. A Wheatstone bridge. Actually, its topic is sensitivity. That's why we kept in the error analysis for idea purpose. But Wheatstone bridge concept. So therefore, concentrate here. What is this? A Wheatstone bridge is balanced with all the four resistances equal to 1K. Okay, balanced. The bridge supply voltage is 100 volt. Okay. Now, the the value of one of the resistances, the value of one of the resistances, the value of one of the resistances changes to 1010. One of the values of resistance changes to 1010 ohm. The output voltage is measured with a voltage measuring device of infinite resistance. Means in that no drop at all in that way. Find the bridge sensitivity. But here, sir, sensitivity means so many units are there. But be clear, he is asking bridge sensitivity only. But if you see the options, volt per ohm he is asking. That's why I told you sensitivity unit will be depending on the condition. I may be expecting ohm per volt, ohm per ampere, ampere ohm, ampere per ohm, or volt per ohm also. That's why see the question. That's why I told you in the error analysis chapter. I told you the sensitivity unit is depending on the given condition. Depends on the given condition compulsory. That you have to concentrate. Clear, guys? Any confusion? Kindly let me know. Right? Now concentrate here, sir. I'll be drawing the diagram now. Yeah, here I will do the total solution. Kindly concentrate. Wheatstone bridge is being taken. Right? This is 1000. What he has given, one of the four resistances. Anything you can take. I am taking blindly like this. Sir, why only that? No worries. Any resistor you can take. 100 volt is there. Okay. What is the corresponding sensitivity? Sir, when it is 1000, what is the E naught? What is E naught? 0. Simply, I'm writing that point directly. Right? When it is balanced, right? V naught 1 is equal to 0. Now, when one resistor, when one resistor is changed to 1010 ohms, then proceed. That's what I'm giving. Concentrate. Sir, I'm finding V naught 2. This is C potential, this is D potential. So therefore, sir, V naught 2 equal to what is it here? VC minus VD or VD minus VC, as you wish. Sir, what is VC? Here also same thing here. Sir, these two are not in series, these two are not in series, because this is the carrying current. That's what I told you. Even though it is carrying the current, yes, we need to treat like open but not open. That's why 100 into which value? 1000 by 1000 plus 1000. This is one value, minus VD 100 into 1000 by 1000 plus 1010. 1000 plus 1010. Kindly see, sir, how can you open? This is a general doubt for electrical people, especially. No problem. Here, I am not opening. Sir, why? Equal to not zero. Check it. 1000 into 100, 1000. Denominator 2000, denominator here 2010. Therefore, not zero means we have not opened the circuit. No need to worry. Everyone give me this value. What is the old? Ashwath, kindly check it. Value. Very good. So approximately I'm writing here 0.25 ohm, 0.2487 something will be there. Approximately 0.25. Yes, very good. Yes, 0.25. Okay, now, sir, sensitivity equal to change in voltage by change in resistance. So how do you know? Means see the option, you will get the idea what he is asking, etc. Change in voltage, what is that? 0.25 minus earlier 0. 0.25 minus 0 by change in resistance 1010 minus 1000. 0.25 by 10. So therefore 25 millivolt per ohm. This is what the answer. Got it? See the option. Clear, guys? Clear, guys? Right. This is one simple question. That only I told you, Dinesh. That only I told you. Even though it is unbalanced, take the voltage division law and finally not equal to zero. Not equal to zero. That's not the point. Okay, and one more question. Sir, you told that bridge sensitivity means delta R by R. Yes, okay. But see the options I told you. He is asking in terms of millivolt per ohm. That's what I told you. Sensitivity has many units. According to the given task, you need to proceed. Suppose if I'm asking like all are ohm per volt, ohm per volt, ohm per volt, ohm per volt, then what you have to do? That's why be clear with the terminology. Very good question. Sir, you told that the bridge sensitivity means delta R by R. Okay. If I take delta R by R, if I take, what will be there? Only millivolt will be there. So no, that is the reason why according to the given task, we need to answer. But you may be asking, sir, none of the above is there. No, yeah, actually the sensitivity unit, if all the three are not correct, then we can go for none of the above. If all the three are not correct, then we can go for none of the above. But one is correct based on the normal sensitivity definition. Sensitivity definition. That's why be clear with the terminology. Yeah, definitely. Sensitivity, kindly after that session also, you can go to the earlier notes. Sensitivity unit depends on the condition I gave you. Yes, follow that condition as it is. Very good. Clear? Right. Like this, so many questions are there. Now, answer one by one from the bridges. Same model. So many people are getting doubt like, sir, under unbalanced condition, how can you apply the voltage? Like I told you, know, under unbalanced condition, we can apply the voltage division law, but finally not equal to 0. You have to take same model. I'm giving everyone. Do this and tell me. Not more than 1 minute. Mridul Sharma, is it 0? Are come on here. 20 into 20, 10 into 10. 20 into 20 is not equal to 10 into 10. The bridge is not balanced. The bridge is not balanced. Very nice. Yes. 3.33. Directly I'm writing here. Sir, this is C. This is D. V naught equal to VC minus VD. What is VC? 10 into 10 by 10 plus 20. Bottom one. 10 into 20 by 20 plus 10. What is the value? 3.33 minus 6.66. But still, our topic is magnitude only. Therefore, 3.33 volt only. Very good, Vasishta. Very good. Very nice, very nice. That's what the speed up you can see, right? Clear? Next one. Do this. Come on. 24.5, 25K, 12.5. Five different answers. Very simple. Again, 25 into 20. First you write this. 25 into 20. 25 into 30, definitely not equal. So therefore, V is equal to V2 minus V1 or V1 minus V2. What is that? 4 volt into 4 volt into 25 by 25 plus 25. Kilo I'm taking common. Minus, what is that? 30 by 30 plus 20. These two series, assumption, but not exactly series, but immediately not equal to 0. Come on, 1 second. Clear? What is the answer? Again, people are giving second option, third option. And Tirupati, you are given 0.4 old. What you are supposed to calculate? Okay, 1 second. 1 second. I thought actually V value. Okay. V value will get something. Okay, right. Sorry. Actually, he is asking resistance value. Actually, I thought V value, no problem. How do you calculate R value? Okay. I'm coming now. But this take it as extra procedure. Find out the V value over there. Substitute this and get it. V value. How much are you getting? 0.4 volt. 1 second. Yeah. 1 second. 0.4 volt. Okay, he is not asking this, but okay, no problem. I'm finding the what is that resistance between these two. Be clear, guys. Those who are not done with the network theory, kindly concentrate. One bridge word will be used now. Sir, this is 4 volt. This is 4 volt. One resistance, one like this. Just I'm rotating this. 25, 25, 25K, 25K, 20K, 30K. Between these two, you need to find out the resistance. Sir, wherever you need to find out the resistance in terms of this, simply that is called as RTH, we can say. Actually thought voltage, but he's asking resistance. No problem, I'm doing. Sir, we need to apply Thevenin's resistance. Sir, what is that? Shirisha, -4. Again, you're saying -4. No, yeah. What I told you, magnitude means you need to give plus only because large minus small always. Be clear. Coming to this, everyone, those who are not done with the network theory, I'm giving the procedure. We need to find out the resistance that is generally called as Thevenin's resistance, we can say. Where you have to find out the things here, simply always be clear, don't stand in the circuit. If you stand in the circuit, you will get confused. So that's why bring those terminals outside like this. Here you need to find out the RTH. First step you do this. Otherwise, standing in the circuit, rotating like this, somewhat complexities will be there after that. So at this point, two sides. What is that? 25K. And at this point, two sides which are there here, 20K. Here also 30K. And it is like this. Okay, after that, sir, whatever the voltage source is there, that is always short circuited. From here to here, this must be shorted. Kindly, those who are not done with the network theory, don't worry. Thevenin's theorem procedure itself is voltage source is there, shorted, current source is there, opened. Okay, after that, simply for simplicity purpose, I'm doing like this. Resistance like this. What is this? This is RTH. 25, 25, 20, 30. Tell me the value. These two are in parallel. Both are in series. So therefore, RTH is dash. Srividya, voltage source open circuit, Noma, voltage source short circuit. Voltage source short circuit, not open. Kindly follow. Voltage source must be short circuited in the Thevenin's theorem or Norton's theorem, etc. Even though people are giving different answer. Okay, I'm writing that. So 25 plus 25, what you are getting? 25 and 25 parallel. What will be there here? 12.5. plus 20 into 30, 600 by 50, you will be getting 12. So therefore 24.5 anyway kilo. Direct answer. People may be getting confused with series parallel notation. Yes, yes, correct. Clear? Right? Now, one more question. Very, very, very beautiful question here. This long back question, but this model is very, very, very popular model. Kindly try this. Okay. Option B, few people 4 milli. Option D, 6 milli. Few people B, few people D. Other, right? Concentrate. It is very, very, very beautiful question here. Completely conceptual. Completely conceptual. What is that? Concentrate here. I'm drawing with somewhat bigger size to have more clarity. Here, resistance is there. Okay. Voltage source, resistance, resistance. Here to here, like this. Okay. Sir, this is Vx. Okay. This is current I. He is asking you to magnitude of current I. This is 1K, 4K, 2K, and this is 2 volt. But be clear, guys. One statement is mentioned that is balanced. Balanced means first point. This potential C, this potential D, both are same. So therefore, voltage across this and voltage, concentrate here. Voltage across this, voltage across this, two will be same. Voltage across this and voltage across this, two will be same. Okay. Now, sir, what is the voltage across this? 2 volt. So automatically 2 volt is appeared here. 2 volt is appeared here. Plus, plus, minus, minus. First step. Everyone keenly observe here. Otherwise, after that, small doubt will be there. Because nothing is there to calculate separately. Everything is there in the diagram itself. 2 volts here. So 2 volts by 1 kilo. What is that? 2 milliampere. Okay. Sir, this 2 milliampere is coming here. 2 milliampere. So 2 milli into 4K plus minus 8 volt will be there. Okay. Sir, across this how much voltage is there? 8. So automatically across this 8 volt because balanced one. These two voltages same. These two voltages same. Sir, 8 volt by 2 kilo. What is it? 4 milliampere. So this 4 milli coming from this side. 4 milli. Sir, 4 plus 2, what is the value? 6 milliampere. That's why nothing is there to write separately because everything is there in the diagram itself. Everything is in the diagram itself. Right? If you practice these type of questions, you will get more idea about KCL, KVL, current addition, voltage addition, parallel, series, everything will be clear. More and more clarity will be there. Clear? Many methods are there. Very simple method is this. Now, I'm repeating for people say, kindly concentrate. First step, VC is equal to VD because it is balanced. Okay. The voltage between these two, nothing but this and this term, nothing but voltage across this will be same. So therefore, 2 volts is 2 volts. Once you observe this, thing is done. 2 volt by 1 kilo, 2 milli. 2 milli is coming like this. Yes or no? 2 milli into 4 kilo, 8 volt. Sir, as it is balanced, this voltage and this voltage both will be same. 8 volt, 8 volt. Okay, after that, sir, 8 volt by 2 kilo, 4 milli. So 4 milli coming like this from this part. 4 plus 2, 6 milli over. Very, very, very simple. Right. See, people are thinking like, who is this? Krishna Sai. C and D should be up. No, sir. Come on here. Come on. The diagram is like this. What is our bit generally? Like this will be there. Supply will be given horizontally, then C and D should be vertical. But he has rotated the figure. That's why be clear. This is C, this is D. Supply is from this side here. Concentrate. Clear? For that purpose only, left side supply is given. I have rotated for easy understanding purpose like this. That's why sir, top and bottom, not like that, not like that. Where you are giving the supply, that you have to concentrate. Okay, right. Let me take one more question. I will do this. Kindly give me the final answers after calculation of all. It is purely in the gate paper. 2-3 subjects combination questions also will be there. So that's why be clear with the terminology. Right. Other method is also there. Tirupati Reddy, you can do it, no problem. Just do it. If answer is there, correct answer, yes, your procedure is correct. Otherwise, check your procedure, no problem. Right now, very, very important. No one should try anything. I'm requesting. Concentrate. Sir, a Wheatstone bridge shown, right? P equal to 1 kilo. This is 1 kilo. Q equal to unknown. R is equal to 1 kilo. S is equal to 5 kilo. Galvanometer resistance is 100 ohm. After that, he clearly mentioned that the Thevenin's source generator voltage, not the normal voltage, Thevenin's voltage. So VTH is equal to how much? 24 millivolt. Be clear, guys. Those who are not complete network theory, definitely doubt will be there in this concentrate. Thevenin's voltage is given. Under the Thevenin's source circuit, the galvanometer current is Ig is equal to 13.6 microamperes. Calculate the value of Q. First of all, Thevenin's source generator voltage means you should know about Thevenin's equivalent circuit. Thevenin's equivalent circuit, you must know, you should know Thevenin's equivalent circuit, compulsory. Compulsory, you should know Thevenin's equivalent circuit. Sir, what is that? Those who are done with the network theory, they know this. But other people, yes, concentrate. In the Thevenin's equivalent circuit, Thevenin's voltage will be there. That is VTH in this 24 millivolt. Always series with this RTH will be there. RTH. And after this is a load terminal. Here we need to connect the load. Sir, among all this, where we are measuring the current, galvanometer only, right? So galvanometer only, we are taking the output notation. That's why load element will be RG, that is 100 ohm. This is what the corresponding Thevenin's equivalent circuit. I'm coming again. Across this, we generally do find the output voltage, etc. Wherever you're finding the voltage or current, automatically that will be taken as actually a load element. Therefore, Thevenin's equivalent circuit is consisting of Thevenin's source voltage, Thevenin's resistance along with that load element. But in this circuit, what is the current through the galvanometer he has given here? 13.6 microamperes. 13.6 microamperes. Okay, now sir, in this entire thing, which is unknown, RTH is unknown. So simply, what is that? VTH, V is equal to IG into RTH plus RG. Simply, V equal to I into R. V equal to I into R total. So from this, tell me the value of RTH. Tell me the value of RTH. Everyone. RTH. Come on, guys. Is it 1.66K or 1.67? Where 1.76 people are giving? No, yeah. 1.67K approximately. Okay. RTH we calculated from the given data. But, sir, for this given network, we need to find out the RTH. What I told you, this is the load element. So what you have to do? Concentrate, guys. Simply open the load element. Here you have to find out the RTH. Okay. And bridge is like this. Bridge is like this. This is P, Q, R, S like this. Okay. Now, what are these values, guys? Concentrate. Sir, 1K, Q, 1K, 5K. This is 1K, Q, 1K, 5K. But RTH already known 1.76 kilo ohm. Okay. Now, sir, voltage source is there. Voltage source must be completely short circuited. Therefore, I am shorting the voltage source like this. Okay. Already I told you, don't stand in the circuit. If you stand inside the circuit, automatically confusion will be there. Come out of the circuit. That's why like this. This is RTH. Already we have got 1 point. 1 second, 1 second. 1.67. 1 second. 1.67K. 1.67K. Okay. After that, sir, here one resistance is there. Here one resistance. This is 1K. This is Q. Here one resistance is there 1K. Here one resistance is there 5K like this. But between these two short circuit. Now RTH, find out the equivalent, simplify and find out the Q value in terms of kilo ohm. Yeah, RTH 1.67. Yeah, correct. 1.67. Make it fast. Come on. Why different answers? Everything I gave you right. Means you are facing the problem in series parallel notation. Some people 6.95, 15.09, 5.13, 1.88. Come on. No one has given correct answer, it seems. Right. Okay, I'm giving idea also how to solve and all. Concentrate. So in this, first thing, these two are in parallel. Okay, so therefore 1.67k is equal to these two are in parallel. 1k parallel with q. These two are in parallel. 1k parallel with 5k. These two are in series. That's it. After that, sir, 1.67k is equal to what is that? 1k and q both are in parallel. So therefore, qk by q plus 1k. R1 R2 by R1 plus R2 plus here 5 into 1 simply 5k into 1k means 5 mega by 6k, right? You bring this side, so simplify. At least now q is equal to dash. At least now. Kindly don't get stuck up with the series parallel I'm requesting. Yes, finally you're giving. Right. Answer will be 4.95 kilo ohm, near to this value. 4.95 kilo ohms, 4.9394, no problem. 4.95, near to this value will be there. Yeah, don't miss this mega. If you miss this, definitely problem will be there. Yes, Vishnu, right. Yeah, one should, only few people give the correct answer, 4.9 something. Okay, 4.93, 4.95, 4.97, no problem. Go back and see the options, which is near. Few people give that 5.05 something also. Take the values, no problem. Nearest value, you can. 4.95 kilo. It is not at all complicated, only lengthy model, 2 marks. But once you know what is that? Thevenin's theorem, very, very, very simple. As a Thevenin theorem is not done for many students, the problem may be there. Clear? Right. Let us solve one more question here. Yes, 4.95k is the answer, correct? Yeah, 4.95, 5.0, 5.1, almost nearest value is no problem because you may be taking 2 digits or 3 digits, etc. Okay, no problem. Right. Vishnu Ajit, can we do this problem Q as the load? No, no. Why means in the entire operation of the bridge, which will be acting as the load, galvanometer is only acting as the load always, because from the galvanometer only we observe the corresponding, what is it? Pointer movements, pointer deflection. Therefore, galvanometer only to be taken as the corresponding load element. Q never. Q is just unknown element, but not the load element, not the load element. Clear? Right? Right. Now, let me take one more question. One second. Try this. It is purely derivation based. purely derivation based. See, I'm giving the break, take the leisure, take the break and come back and try to solve, try to answer this. Otherwise, I will explain clearly in detail. No need to worry. Yeah, Pranit, that is okay, but I wanted to give simple procedure. You can solve it, no problem. After giving the equation, any type of mathematics is there. Yes, you can proceed with that mathematics. That's it. That's your technique, no problem. Right. I'm giving now. See, this is R1, R2, R3, R4. Right? Now proceed. But first take the break and come back. Right, come back. Got it? Anyone? Option C, sir. Okay, very good. Many people give the answer. Right. See, let me explain now clearly, step by step. I'm taking this entire diagram clearly. Here, this is R1 is equal to R. R2 is equal to R. R4 is equal to R plus delta R. Kindly concentrate. I'm explaining step by step concept. Kindly concentrate here. Sir, here resistance is placed. R3 is equal to R, for example. Sir, the given circuit is balanced or unbalanced. The given circuit is unbalanced. Why? R into R square, R into R plus delta R. That is unbalanced. That's why, in order to make this circuit as the balanced circuit, the small voltage source they have added, that is V. Means after adding this V, with respect to this V, some current will be flowing, drops will be changed. Then he said that the bridge is balanced. That's what the point. Now find out the value of, what is it? Find the value of delta R. He's asking the value of delta R is dash. Clear? So what is the value of delta R? Now concentrate here. So in this, first, is it terminology I'm taking here? This terminology will be useful in next chapter, that is AC bridges. It will be useful. What is it? Here voltage across this one is E1, E2, E4, and here to here E3, from here to here total. Okay, after that, sir, this is current I1. Same current is flowing here I1 because balanced. Here I'm taking some current I2. Same current is flowing I2. Right, after that, sir, balanced means C and D potential both are equal. Okay, sir, if C and D both are equal, which voltages are equal? E2 is equal to E3, E1 is equal to E4. Okay, right, now I'm writing now. Concentrate. From balancing conditions, what is that? E2 is equal to E3 in this number. Check it. E2, E3, because both will be same by VC is equal to VD, and also E1 is equal to E4. If these two are equal, these two are also equal. So therefore, E1 is also equal to E4. Okay. Now, from the circuit, kindly concentrate. If you understand this point, the thing will be very clear. So what is it? Here, sir, these two are in series. Resistance is R and R. Resistance is R and R. So therefore, my question here is, sir, E1 and E2 will be same or different? Same. Why? Sir, I1, same current. The two, same resistance. So automatically, same current, same resistance. What is it here? Drop will be same. So therefore, from the circuit, E1 is equal to E2. E1 equal to E2. So what is E1 from the balancing? E4. What is E2? E3. So indirectly in this question, all EMFs are equal. All EMFs are equal. He has given. Okay, check it here. I'm starting from E1. E1 equal to E4. E4 equal to E3. E3 equal to E2. E2 equal to E1. Yes. So therefore, all are given equal, but few are given directly, few are not given directly. That's what the point. Okay. Now let us verify. Sir, what is E4 formula? What is E4 formula? I2 into this one. Okay. E4 I2 into R plus delta R. Sir, what is E3? E3 means I2 into R plus V, because this voltage drop I had already branch. So therefore, E3 equal to I2 into R plus V. Okay, after that. Sir, E1 equal to E2. Okay. Sir, this voltage both are same. Why? Same current, same value R and R only. Therefore, so what is E1 and E2 equal? The two half of the supply voltage. Why? This will be equally divided because equal opposition. So therefore, what we can write now? This is equal to E by 2 means this also equal to E by 2. Now I'm writing here. This is equal to E by 2, E by 2. Okay. Now I'm writing from this first one. Sir, I2 is equal to E by 2 R plus delta R. Next, I2 is equal to E by 2 minus V by R. This is equation 1, equation 2. Sir, I2 both are set. Up to this complete technical one by one step you have taken. Now you have to take simple mathematics. Now from 1 and 2. Proceed and tell me from 1 and 2. At least know those who are not done, at least know. Right. What is it? Delta R is equal to, what is the value? C option will get correct. Right? 2RV by E minus 2V. It is also 2 marks model. These type of questions also may be given in the paper. These type of questions also may be possible. So this is a total discussion, elaborated discussion with all varieties of questions, everything I gave you. Clear? Right. Next. The next topic is fourth method. What is the fourth method? Ohm meter. Fourth method is ohm meter. Sir, what is ohm meter? Kindly concentrate. The ohm meter is nothing but it is a resistance measuring device, but concentrate. It is not directly resistance measuring. This is basically an ohm meter. Basically, sorry, basically an ammeter. Nothing but ohm meter is not the resistance measuring device directly. It is basically an ammeter. It is basically an ammeter. And here, in which the current scale, concentrate here, in which the current scale is calibrated. The current scale is calibrated in terms of resistance scale. This is what the actual point. Current scale is calibrated in terms of resistance scale. So what do you mean by that? Pradeep, Jadhav Pradeep, kindly check your answer. Option is C. Even after explanation of this one, if you are saying that, sir, I got B, means you have to verify. You have to verify your procedure. Okay. Now, here, concentrate here. Basically, an ammeter in which the current scale is calibrated in terms of resistance scale. Means, be clear, sir, the device is basically an ammeter. Basically an ammeter, but not the basically ohm meter. No, it is construction wise everything ammeter only, current measuring device only, but only the scale is calibrated in terms of resistance. The scale is calibrated in terms of resistance. Sir, how? Concentrate. And the second one, I'll tell you that second one. Sir, our topic is DC bridge or AC bridge? DC bridge only still. So therefore, this is generally PMMC type, because DC, which is the better, I told you, PMMC instrument. Yes, that only they are using. Clear? Right? Okay, now, sir, what is this? Means in this, there are two types of devices are there. One is shunt ohm meter, series ohm meter. Shunt ohm meter and series ohm meter. Right? What are those? Very, very important here. So far, we have taken so many times what is the calibration and all we have taken. Now I'm taking the clear cut elaborated explanation. What is calibration? Everything I'm going to show. Concentrate. In the potentiometer, we have seen calibration for one time. Now I'm going to show one more time calibration. What is it? Let us see now. First one, that is shunt ohm meter. I'm taking. Right. So what is the shunt ohm meter? You know, concentrate here. This is the general circuit. Like this. This is R1, this is R2, some supply voltage V. Consider guys, everyone, this is complete experimental explanation I'm taking. Experimental explanation. Kindly concentrate. Sir, here, across this, resistance is being connected. Across this, resistance is being connected like this. Okay, this is the general circuit of ohm meter circuit diagram. Okay, now very, very, very important point here is concentrate, guys. Concentrate. Sir, first step, what do you mean by that? First, keep R some value. Means we are not measuring first. We are designing the device. We are calibrating the device first. After that, we will be going for measurement later. So that's why concentrate between these two, A and B. Suppose A and B terminals are there. No, between these two, connect the value of R. Which one? Known value. How do you know? Means that is a standard value while designing we take. So that's why first point, sir, if R is equal to infinite. Sir, if R is equal to infinite, what is the value of current through the ammeter? If R is equal to infinite, what is the value of current through the ammeter? Means, sir, if it is infinite, open circuit. If it is open circuit, the total current is flowing through this circuit only. Total current is flowing through this circuit only. So therefore, maximum current, we don't know. That is V by R1 plus R2. So simply I through the ammeter is maximum possible. Maximum possible. People are giving 0. Come on, guys. Varsha and Srividya, concentrate. This is infinite. Ammeter is here. Ammeter is not in series with this. Concentrate. Ammeter in one place, resistance in some other place. I'm comparing this versus this. So therefore, if you're providing the open circuit here, there will not be any current. So therefore, total current will be flowing through this only. Total current will be flowing through this. Clear? Okay, right. But okay, I see current through this R, okay, but I'm asking A. Okay, right, correct. Sir, after that, I'm reducing the SAR means 1 mega I'm keeping, for example, 1 mega. Sir, if I'm keeping 1 mega, current comes over here. At this point, current will be divided. Current will be divided. Yes or no? As the current is divided, what we can say, current through the ammeter reduces. Again, I'm increasing the R. Sorry, again, I'm decreasing the R. Again, what is it here? Current will be changing. Are you getting my point or not? So what is it? I'm coming again. Sir, R equal to infinite. Total current will be flowing through this. I'm reducing the R. Therefore, through this path, current will be increased. Through the ammeter, current will be decreased. Like that. Finally, if I keep R equal to 0. Finally, if I keep R equal to 0, sir, current is coming at this point. One is resistive path, one is zero resistance path. So obviously current flows through shortest path, zero resistance. So therefore current through the ammeter will be 0. So these are the values we obtained from the experiment analysis. Clear? Now concentrate here. After getting these values, what a manufacturer does, concentrate. What he does, simply they open the ammeter. They open. Who? Manufactured only. In that entire instrument, which scale was there? 0 to I is equal to I maximum. That is full scale or something. We don't know. 1, 2, 3, 4, 5, 6, something. Right? What was the device? PMMC ammeter device. Okay. Now what they do? Very, very simple. They are nothing but we don't change the construction. We don't change any physical construction parameter. Only simply by opening that. On this scale, one more scale is placed. One more scale is placed like this. Sir, this is the current scale. Sir, I equal to 0 is there. If I equal to 0, what was the R value in our experiment? 0. So therefore 0. This is R. Otherwise, I'll be writing here R is equal to 0. Like that. So I equal to X ampere, R equal to something like this. Keep on taking all the different values. So I equal to I maximum. What is the value of R? Equal to infinite. Now, by removing that, they will keep ohm symbol. They will keep ohm symbol. But be clear, practically, they will erase this entire thing. After doing entire thing, they will erase this. Only this device will be given to you. Sir, this device is showing which value? Resistance only. That's why they will keep this value as simply ohm. This will not be there here, but in the classroom I'm not erasing. If I'm erasing that, how we are getting, we get confused. That's why resistance and current scale both I'm keeping. So that's why simply A by ohm I'm writing here. Now tell me, is it concentrate, is it an ammeter or ohm meter? It is basically an ammeter only. Basically an ammeter only. In which the current scale is calibrated in terms of calibrated into, I can write in the simple way, calibrated into which scale? Resistance scale. That's what the point. Right now, same thing. Ammeter, but showing this one. Now I'm asking one question. Sir, ohm meter is responding for current or resistance. Come on here. This ohm meter is ohm meter only. A by ohm, like that will be there. This ohm meter responds for current, response for current or response for resistance. Means be clear, response for current only, but indicating which value, consider indicating which value, very good, indicating which value? Resistance value. That's why ohm meter is basically an ammeter. This pointer is responding for current only, but showing, indicating which value means simply resistance value. That is what the ohm meter. That is what ohm meter. Yes. This is a complete construction and corresponding calibration. That's why if you understand this, okay, if you know one parameter, we can calibrate the device to some other parameters also. That's what actual point. Right? Okay, now in the same way, I'm taking series ohm meter. series ohm meter. Very simple, sir. Here, one resistance, ammeter, one resistance. Like this, the circuit is there. Okay, this entire thing is our circuit. Okay, now between these two, we are going to keep resistance R. This is R1, R2, V. Same experiment, same analysis. Concentrate here, concentrate. Here, if R is equal to 0, concentrate here. If R is equal to 0, so if R is 0, concentrate here. If R is 0, complete thing is short circuit. If complete thing is short circuit, source will be giving the supply. Means from this source, supply will be there. If any doubt is there, I'm changing this polarity, no problem. Okay, so that's why be clear. And in the same way, what I'm taking now, if R equal to infinite, if R equal to infinite, so it is completely open circuited. It is completely open. If it is open, source is open. There is no supply to the corresponding circuit at all. That's why if R is 0, so R is infinite, current is 0. I'm coming again. If R is infinite means, if R is infinite means there is no path at all. If there is no path, automatically no current flows from the source to the circuit. So therefore, automatically no question of current flow. Clear? Okay. Now after that, sir, I'm reducing the resistance value. In the reducing, if I'm reducing the system, is path is formed. If the path is formed, current will be flowing. So far 0. Now slowly current is increased. So therefore R value, I value, R value, I value, R value, I value. Finally, I'm making R is equal to 0. So if R is equal to 0, from this point to this point, minimum resistance is offered, least resistance is offered. Automatically, maximum possible current will flow through this. So therefore, I is equal to I maximum. Clear? Concentrate here. Few people are asking that, so do we vary current from 0 to infinite? I don't understand. Where did I vary current 0 from infinite? Current is 0 from full scale value only, but resistance is varied from 0 to infinity. Here also, resistance is from 0 to infinite, but current is from 0 to its own, whatever the thing used, that full scale value. That is what the point. Clear? Again, same story. Again, same story. What is that? Instrument. Okay. Which scale is there? Which scale is there? I is equal to 0 to I is equal to I maximum something 0 to 3, 0 to 5. That depends on the given question. And this one, A, very simple. They open that and give one more scale. What is that, sir? I is equal to 0. R is equal to infinite. This is what the change. And some values are there. Okay. Here also same thing. Accordingly, some values will be calibrated here. And I equal to I max means R is equal to 0. R is equal to 0. Now they will erase this entire thing. Simply ohm symbol. But in the classroom, I'm showing as it is. Clear? Right. Why two resistances? Simply, you cannot, if this resistance is not there, this resistance is not there, what is it here? This ammeter becomes in parallel circuit. That's why we need to take this. So why this resistance? If this is not there, directly current is flowing. No, that's why. But I want to say that only. You can take any sort of circuit here, any sort of values here. No need to worry. But I'm taking one of the circuit and I'm showing like this. But be clear. The note here is concentrate. I'll go back, just concentrate. Here, the negative scale is, sorry, the reverse scale is, there in, the reverse scale is there in, which one here? Series ohm meter. The reverse scale is there in series ohm meter. In that way, you have to take it. What is that? Reverse scale, infinity to 0. But here, 0 to infinity. By the concept only, I told you. In this is a general circuit. This is 0 to infinite, a ammeter to resistance. Here also, what is that? Infinity to 0 ammeter resistance. This is called as ohm meter. Nice. Here, people resistance R is 0, I is I maximum. How? Come on here. If resistance is 0, sir, between these two, how much resistance is there? Minimum. If minimum resistance is offered by this element, maximum possible current will be flowing or not? Yes, that's not the point. So that's why from here to here, as we are off, suppose in the circuit at one point, at the load point, if the minimum resistance is offered from the source, maximum current will be flowing. Yes, maximum possible will be available. That's why I've taken I max value. Right? Right. Now, I'm coming to that. I'm coming to that because I did not see that. Wait. Sir, because of this. Right. You take anything, but this is the general standard circuit. Take the circuit as it is. If this is there, that is there, what happens? Not required. These are the standard circuits. Kindly follow. But the question here is, sir, medium resistance 0 to infinity to 0. Sir, the ohm meter is used to measure infinity to 0, 0 to infinity. But still, this ohm meter comes under, why comes under medium resistance measurement only? Why? Medium resistance means 1 ohm to 100 kilo ohm only. But our circuit shows that up to infinite. Here also up to infinite is there. But why the instrument is ohm meter is only for medium range, not for all the universal values? That's what the question. Kindly answer properly. Why it is not for all the values? Why only medium range you have taken? Very simple point. Right. Very simple. Different answers you have given, but very simple. Sir, here this is 1 ohm, for example, 10 ohm, for example, 1K, for example, some values. Sir, my question is any number here. This may be any number. Let me take 10 mega or 1000 mega or 500 mega or 2000 mega, any number. So my question is, sir, any number to infinite, any number you take, 10 power 100, 10 power 1000, any number you take, from that to infinity number means, is it just like a sudden jump or not? Any number you take, 1 crore, 10 crore, etc., etc., any number to infinite, sudden jump will be there. That's why this scale is very non-linear portion for resistance. Why? Suddenly jumping. Here also 0 to some value to 0, suddenly drop will be there. No, that's why by the concept of mathematics, what they take, no, between these two, some non-linearity will be into picture in the resistance category. That is the reason why generally what they do, yes, below 1 ohm, direct drop will be there up to 0. So non-linear. Here 100K, they have taken best range, not more than 100K, not less than 1 ohm. That's why simply this is generally suitable for the measurement of 1 ohm to 100K. Other than that, there is no any other technical reason. Simple logic is, you see, simple logic here. From any number, if you are going to 0, sudden drop will be there. Isn't it? But any number to, if you're going to infinity, sudden incremental. Sudden incremental means what? Non-linear nature. That's why between these two, conceptually non-linear. That's why by this entire concept, simply they will keep 1 ohm as the minimum in this test experimentally, 100 kilo ohm as the final value. After that, infinity they will keep. Between these two, they don't take, because sudden change anything, no problem. That's why the better measurement is 1 ohm to which one here, 100 kilo ohm. We say that is not the simple idea. Other than that, there is no other reason at all. Yes, Akash, infinite refers to 100 kilo, not exactly, but that only approximately. Right, ohm meter is non-linear scale, definitely. That's why I told you scale is different. Scale is different. But here scale is linear. Sir, with linear, how do you get non-linear? So far I have taken the complete discussion. 2 times I explained. I'm explaining once again also. Sir, any number to 0, sudden drop, non-linear. Any number to infinity, sudden rise, non-linear. That's why they will take 1 ohm to 100 kilo ohm approximately, because practically up to infinite is not at all possible practically. That's why ideally we can take, but practically 1 ohm to 100 kilo ohm only. General idea, that's it. Clear? Right? So this is the total method regarding ohm meter. This is regarding ohm meter. But be clear, ohm meter is basically an ammeter, which ohm meter is basically an ammeter in which the ammeter scale is nothing but current scale is calibrated into resistance scale. Calibrated into resistance scale. Clear, guys? Can you respond? This is second time I have taken calibration process. Potentiometer I have taken, and here also. Right. Very good. Yes, that's what. Imtiaz Pasha, yes, starting and ending non-linear, simply we say non-linear scale. No need to worry. Correct. Now, next method is high resistance measurement. High resistance measurement. Sir, what is this high resistance measurement? Be clear. Be clear. Sir, what is it all I told you in the discussion of day before yesterday? What is it? Greater than 100 kilo ohm. Greater than 100 kilo ohm. Okay. Application is measurement of resistance only. Nikhil, application of that ohm meter is measurement of resistance only. You are forgetting the topic. And Vishnu, so analog voltmeter will have both ammeter. That end I told you. I think you forgot. I think you did not. You missed. I think this scale will be removed practically. This scale will be removed practically. All I told you. But in the class, I cannot remove because you need to understand current scale. Here also, I told you this will be removed. This will be removed. So kindly concentrate. Don't miss the topic. I told you already. What is that here? This scale, current scale will be removed. Only resistance scale will be shown. Right? Okay, now, sir, high resistance measurement. What is that? Greater than 100 kilo ohm. In this also, 4 methods are there. 4 methods are there. What is it? What is it method? You know, first one, direct deflection method. Direct deflection method. Right? Pratik, did you attend my yesterday's class? Pratik Bhosle. Did you attend my yesterday's class? Respond. Yeah, in that application is there. Where do we use medium? Where do we use resistance? I give an example: armature winding resistance and what is it? Shunt field winding resistance. In that places, we are going to use this measurement technique. Okay, and series ohm meter is non-linear. Obviously, series ohm meter is non-linear. Shunt is also non-linear because here 0 to infinity, obviously, in one small device, 0 to infinity you are keeping means there is no question of linearity at all. Simplest mathematics. In one small limited size, you are trying to keep unlimited value, non-linear scale automatically. Both meters are non-linear scale only. Right, Nikhil? Sir, I mean where we will measure such high resistance with these meters. That only I told you. Go to the yesterday's class. What I told you in the example class. What I told you. High resistance example, diode reverse bias. Suppose in my one application, diode reverse bias is to be measured. Yes, we go for high resistance application. Suppose I want to measure insulation resistance. I give an example. That only. In the insulation resistance measurement, we are going to use this type of measurement. That's it. Clear? Right. And one more thing. Sir, instrument scale means starting to ending. But don't ask, sir, here to here linear, here to here non-linear. What we have to answer? Totally instrument scale is non-linear. Totally instrument scale is non-linear. So don't need to worry. Right? What is application here? Insulation resistance. Insulation resistance. Okay, no problem. Yeah, Nikhil, as you forgotten, I have revised, no need to worry. Okay, right, sir. Direct deflection method. Second one is loss of charge method. Loss of charge method. Third one is Meg-Ohm bridge method. Meg-Ohm bridge method. Not mega ohm bridge or Meg-Ohm bridge method. We say. Measurement subject is completely important. Right? Next. After that, Meg. These four methods are there. But my question is, before going to take the entire topic, I'm asking, sir, high resistance measurement methods are simple, or low resistance method is simple, or medium resistance measurement is simple? Which is simple generally, practically speaking? Respond everyone. Which is simple comparatively? All are simple only, but which is more simple comparatively? Low, medium, high, all options you are covering. Okay. Come on. I told you again, you forgot yesterday. Low resistance measurement must be taken more care. Why? 0.1 ohm not neglected. 0.05 ohm not neglected. Means their high accurate method is required. That too, more concentration is required such that 0.01 cannot be neglected, because less than 1, 0.5 cannot be neglected. 0.2 cannot be neglected. Isn't it? But if you come to medium, 1 ohm neglected, 2 ohm neglected, no problem. In the high resistance, 10 ohm also we can neglect. Why? High resistance in the range of megas of ohm compared to 1 mega ohm. Can I neglect 5 ohms, 10 ohms? Yes, that's why comparatively high resistance measurement is more simple, because in the low resistance, people give that low resistance. Yes. How low resistance? Yeah. In the low resistance, each and every value must be concentrated. That is the reason why low resistance is somewhat not complicated compared to this complicated, because 0.1 cannot be neglected. Means all the values must be perfectly considered. But in the high resistance measurement, automatically few values can be neglected. Right? Easy, sir. See, actually, low resistance only two methods are there. Easy, understand. That is not I'm asking here. Measurement technique means small values are to be considered, cannot be neglected. That's why concentrate more and more on the entity. Low resistance, small values cannot be neglected, means more concentration. Medium, 1, 2, 3, 4, 5 neglected. And high resistance, 5, 10, 20 also neglected based on the content. That's why more simpler method is this only. That too, I'm going to show that also. First one, direct deflection. Very, very simple here. Just 5-10 minutes topic only. Very, very simple. But be clear here. Be clear. See, in the gate point of view and in the prelims ESC point of view, Megger, I will explain in the simple way only, objective way only. But those who are writing the ESC conventional, those who are writing the ESC exam, in the conventional explanation, mains explanation, I'll be taking all the different derivations along with that. In this topic, Megger complete construction, step by step. What is a coil? What is this coil? How the things will be there? Everything will be explained later. But in the objective, this is gate and prelims class. Therefore, how the objective way of concept is there, I'll explain that. But don't worry, those who are writing the ESC, this topic will be taken again in the ESC conventional paper. Clear? Right. Sir, first one. Direct deflection method. Very, very simple. Direct deflection method. So the name itself indicates directly the corresponding pointer is getting deflected. Directly, the corresponding pointer is getting deflected. Yeah, definitely. See, many people, actually, I would like to give one more example. Sir, I'm preparing for GATE. Can I write ESC also? No problem. Few people are saying that, sir, I'm preparing for ESC. Can I write the GATE means? Yes, last year only, 2019, one example I'm giving. One student took the coaching for ESC exam, ESC, right? But the student has written GATE exam also, right? In the ESC prelims qualified, GATE also rank. How much rank? 166 rank. That student is presently studying in ISC Bangalore. That's why GATE and ESC, both prelims and GATE per objective, both are almost same. Only one or two subjects are different. That's it. Other than that, everything is same only. No need to worry. Everything is same only. No need to worry. That's why even though you are preparing for GATE, you can attempt ESC. Preparing for ESC, you can attempt GATE also. But mathematically more in the GATE, conceptually more in the ESC. That's why I'm covering both. One second. Coming to this, yes, coming to this direct deflection method. Right. See, in this direct deflection method, what is the point? Yeah, okay. People are asking. If I give an example, from that example, one question. Okay. So 166 ranks means PSU, yes, but the student was more interested in studying the higher studies. That's why went to ISC Bangalore. That is your interest. 166 rank. Obviously, yes, PSUs are eligible. You will get PSU. Undoubtedly, you will get PSU. Definitely. That is people's interest. Few people are more interested in doing the job directly, but few people are interested in going to higher studies, MTech. That your wish. But both are good only, no problem. What is package for PSU and up to which rank? Everything I'll tell you later. Just only two things I'm giving. I'll give you everything later. No need to worry. At any time, I would like to just I need to take the permission. I'll tell you. Otherwise, if that is not possible in my class only for 10 to 15 minutes, I'll give the brush up idea. No need to worry. Sai Charan, they will not give like that. They will not give like that. Right? All topic syllabus they will give, but more study, less study like that, they won't give. Right. Okay. Now, okay, come back to my topic. So direct deflection is the simplest method here. The resistance R. Okay. And here, voltage source, battery voltage source. Battery voltage source. Like this. So this is V. This is V. Okay. Sir, in between these two, we connect simply ammeter. Direct answer, direct deflection. That means this is high resistance we are taking, very, very high resistance we are taking. Okay. Now, simply connect the ammeter, connect the battery voltage means very, very small, 10, 20, 30 volts only, not more than that. That is battery voltage only we take, only battery voltage. Okay. Now the point is simple logic here. We need to find out R, whatever the voltage we supplied, whatever the current shown by the ammeter, that is giving the resistance over. Sir, in this, contact drops, no need to worry. Ammeter drop, no need to worry. And voltage source contact drop, no need to worry. Voltage source internal drop, no need to worry. Why? High resistance, no. Blindly contact drops can be neglected. That's why the simplest method is this only. Very, very simplest, direct answer. But in this, some limitation is there. What is that limitation? No, concentrate. Suppose Everyone try to understand this logic. Suppose this instrument is having some scale, we don't know, some scale 0, first division, second division, third, fourth, like some divisions are there, some current we don't know. Sir, R is equal to something here, something here. One from this we have got R is equal to 10 mega ohm. Okay, happy, right? Okay, but be clear, sir, this R is connected in the circuit. Assume that the pointer has shown first division, starting division. Okay, V by the starting division value of current, V by current equal to, we got it. That assume as 10 mega ohm. What is it? Unknown resistance is connected. With this resistance in this circuit, with this closed path, current will be flowing. Assume that that current is showing one division. That current is giving one division displacement. Okay. Yes, it is giving one division displacement. Okay. Yes, sir. V, what is this one division displacement? Based on the scale, you will write, you will get the answer. Assume that that is 10 mega ohm. Okay, happy. But suppose R1 over, I am keeping R2. That is, suppose greater than 10 mega ohm, but we don't know the value. Range is known, but don't know the value. Sir, is this method suitable now? No. Why? If the resistance is more than the earlier value, for example, sir, for this 10 mega ohm, it was showing first division. But if you're increasing the resistance value, the pointer will be in between. The pointer will be in between 0 and first division. So if the pointer is showing, staying in between 0 and first division or 0 and any division, can we get the proper value? No. We cannot say exactly half or 20 or 30 like that. Simply this is 0, first division. The pointer will be like this. So if the pointer is like this, how much current is to be written? We cannot write. That is the reason why with this entire method, what is it here? Limitation is there. If the corresponding resistance are taken, the limitation will be there in this. But in the corresponding limitation point of view, we cannot use this entire method for various or wide range of applications. That is what the problem. But in my example, up to 10 mega working properly. But if the resistance is increased, the current will be reduced. Pointer will be showing below one division. Below one division. So below one division, as the operator, how can we sense it? No way. That is the reason why I'll be taking the fourth method first, measure. We will be going to measure directly. Right, sir, what is measure? Already told you in the conventional point of view, complete construction, step-by-step hour. But in the objective paper preparation point of view, simple technique is there, concentrate. Measure. What is measure? You know, resistance I'm taking. Resistance R I'm taking. Okay, after that, sir, here ammeter A, okay, here, sir, here and here, right? We don't connect the supply battery 10, 15, 20 volts. No, we are going to connect one machine here. This is simply called as generator. Okay, that too. Those who have done the experiment with Megger, they can recollect this. This is hand-driven generator. Hand-driven means in the laboratory of Megger, in the laboratory of measurements, experiment with the Megger, the student has to rotate the handle, rotate the shaft of the corresponding generator. Means generator, mechanical to electrical. But who will give mechanical means operator, that is student only. Those who have done the experiment, they can understand this. They can understand. Otherwise, simply take it for granted. Right. On transformer workshop, did sir excellent work to do. Which one? I did not understand, Vasishta. Okay, just elaborate it. I'll tell you. Okay. So what is the point here? Okay, those who have not done the experiment, no need to worry. Those who have not done the experiment, no need to worry. But those who have done the experiment, they can understand this practical view. Otherwise, concept anyway, I'll explain. What is the concept? What is the concept? You know, simply. Yeah, okay, very good, very good. Right, very good. Sir, simple logic, sir. Here, mechanical input is to be given. Mechanical input is to be given means you can vary the mechanical input. As you are varying the mechanical input, whatever the voltage output of this generator can be varied. As you know, now first observation, here this is a fixed voltage. I told you some battery voltage, fixed voltage. We cannot vary this, but here we can vary this. Okay. Second thing, if you keep on giving more mechanical input, voltage magnitude also keep on getting increased. More and more and more will be there. So that's why among these two, which can be utilized for wide range of application means Megger only. How? I'm coming now. Same logic, sir. Finally, in the simplest way, I is equal to V by R. So same formula. Yes, but be clear. I'm coming again. Sir, one R is placed. Okay. Some voltage is there. Some voltage is there. Current is right measure. Sir, here R is equal to I'm writing V by I. Sir, some voltage is there, some current is shown. Assume that this ammeter, concentrate here, showing the one division only, first division only for example purpose. Okay, at first division is shown. Assume that this is 10 mega ohm. Okay, happy. Done. Our answer is done. Now, suppose now R2 we are keeping, which is greater than 10 mega ohm, for example. Sir, if you are keeping greater than 10 mega ohm, in this, what was the problem you have seen? Now the pointer shows which value? In between 0 and 1. In between 0 and 1. Sir, in between 0 and 1, this was a drawback here. But in this, don't worry. Increase the voltage. How do you increase the voltage? By giving better mechanical input. Increase the voltage. Sir, if you increase the voltage, current produced will be increased or not? Yes, as that current is increased, this pointer tries to move towards the first division, etc. That's why in this Megger, we are able to control the current or control the pointer movement. So that's why among these two, which is having wide varieties of applications, here means variable voltage is there, and the two large voltage is also applicable. That is the reason why we are using generator. People are asking still, sir, why the generator? I'm saying that only with this generator we can develop the voltage 100 volt, 200 volt, 300, 1 kilo also we can generate. Means as we are able to control the voltage, we can control the current, we can control the pointer movement also. Yes, we can measure wide varieties of corresponding resistance. That's why among these two, I'm coming again, among these two, which is having wide varieties of applications means Megger only. That's what the point. Suresh, is it clear? Suresh, is it clear? Why the generator is used means to get the controlled voltage, to get the increased voltage, to get the variable voltage. Clear? In that way, we need to measure. Yes, correspondingly, mechanical input is to be given. So fast rotate, slow rotate. That's why I told you, corresponding to the pointer movement. That's why you keep on rotating that. Simply observe the pointer. If it is showing it corresponding division value like this. Suppose the pointer is at this one. Now you need to stop the increase in speed. Means actually indirectly, internally, some clutch will be there. That clutch will be maintaining the constant speed wherever you want. Okay, pointer is showing the corresponding scale division like this. For example, at the time, if you stop rotating that, automatically with that, some clutch will be there. That clutch will be the centrifugal switch, we can say, centrifugal clutch, we can say, that will maintain the constant speed. Yes, constant voltage, constant current. Yes, we can note down some current because it is showing the scale division value. Yes, we can measure the corresponding value. This is what the complete experimental approach of this one. Any confusion, kindly let me know. Which generator? Any DC generator, no problem. Any DC generator, no problem at all. Right. Very good, very good, very good. Yes. Dinesh, correct only. Yeah, definitely shock will occur at the terminal speeds. Yes, safety is required, right? This is a hand-driven generator we are using. Kindly take this as it is, hand-driven generator only. Why not that? Why not this? Means any variable voltage supply related generator is okay. No need to worry, right? Definitely, definitely. See, this is what the objective way of preparation. No need to worry. But for ESC people, in the main separate class will be there. In the mains, separate lengthy questions and correspondingly derivations, everything will be taken at that time. Megger with point-to-point construction. What is the coil? Where you have to keep? How to adjust? Everything will be taken. No need to worry. So that's why the final question I'm asking: among these two, which is having wide varieties of applications? Come on, which is having wide varieties of applications. Can you tell me comparatively among these two, comparatively, which is having wide variety? Yeah, definitely Megger. Yes. Right now, people are getting confused. Like, sir, explain once again. Nothing is there. Yeah? Very simple. Yeah. Here, simply what I've taken. I'm repeating. Here, ammeter is there. Here, resistance is there. Here, voltage source, but variable voltage source. If the ammeter pointer is between the two divisions, don't think bad, are come on, I cannot measure. No, simply increase this voltage. If you increase this voltage, automatically you can control, but not the battery, not the battery. This is which one here? Simply we are using generator. That's it. Why? If it is a battery, you can increase up to 30 volt only in the laboratory. Yes or no? Regulated power supply 30. That's why we are using generator. If it is a generator, automatically, yes, we can get the corresponding incremental up to 1K, 2K also will be there. Yes, we can get the better value measurement. Yes. How to know V generator? That will be displayed. No need to worry. No need to worry. I displayed no here. If I display like this, it will be there. No need to worry. This is the objective way of explanation. No need to worry. A total concept I gave you. Megger is only for high resistance. Megger is only for high resistance. That is insulation resistance, we say. After that, other two methods are very, very simple. That is second method. What is that? Loss of charge method. Loss of charge method. Sir, what is loss of charge method? Very simple. Loss of charge means discharging concept. Loss of charge means discharging concept. Clear? Right. Sir, loss of charge method. So that is simply discharging method. Sir, which is the best discharging element? That is capacitor. So therefore, very, very simple here. Concentrate. It is also explained in two ways. Concentrate. I'm explaining both the ways. This is my unknown resistance. Okay. And across this, capacitance is connected. C value. Why? Discharging. So capacitor we take. Okay. And here, across this, voltmeter is being connected. That voltmeter senses the value VC. After that, here some switch action will be there. Some switch action will be there, and here to here. This is supply voltage VI. Concentrate here. First, at the time of experiment starting, switch is closed. Once the switch is closed, automatically total supply will be applied. Total supply will be appeared. Total supply will be appeared across this entire circuit. Okay. Now, during the supply on condition, capacitor gets charged. Capacitor gets charged until some value, for example. Then I'm opening the switch. Sir, if I open the switch, supply will be disconnected. Then which will be acting as the source? Which will be acting as the source means capacitor. Now it tries to get discharged through the resistor. Discharged through the resistor. So therefore, what is it here? Discharging method. That's what the point. Okay. But here what I told you, no, concentrate guys. Here I told you capacitor to be connected across that voltmeter like that. Otherwise, by removing this entire thing, we can connect electrostatic voltmeter. So electrostatic voltmeter also capacitive function and voltage indication will be there. You can take anything because capacitor only will be there in the electrostatic and voltmeter will indicate the value. No problem. You can take anything, but easy understanding purpose, I am taking one capacitive element and voltages, no problem. Voltmeter, no problem. Sir, now discharging, through the discharging, that when the discharge, capacitor is discharged, right? VC is equal to electrical people, transient analysis. This topic is being taken. But other people, those who are not done with the network theory, those who are not done with the network theory, so kindly concentrate. Kindly concentrate. The formula I'm giving directly, you can have this entire derivation, the network theory transient analysis. What is the formula? Vi into e power minus t by rc. E power minus t by rc. Right? It is discharging. How can I say discharging? Simply e power minus theta means it is decaying curve. So discharging. Sir, Vc known from this, Vi known from this, some voltmeter, etc. R unknown, C known value, and time of discharging also they will give in the question. No need to worry. So therefore, everything except R is there. That's why it is purely, but the transient concept is, same that only. Mathematics only. Sir, Vc by Vi is equal to e power minus t by rc. E is coming over here. Ln Vc by Vi is equal to minus t by rc. Minus t by rc. Sir, if I want to cancel minus sign, ln Vi by Vc, reverse the logarithm, then t by rc. Finally, sir, r is equal to t by c into ln Vi by Vc. At any cost, you need to remember this formula. This is what the corresponding value. In which method? Loss of charge method. What is it? Simply, supply is to be given. Capacitor charge. Okay, then remove the supply. Now the capacitor is getting discharged through the resistance. If it is discharged through the resistance, automatically, yes, R will be so and so. Mathematically, you can calculate. Clear? This is one method. And other method is very simple. That is Meg-Ohm bridge. Very, very simple. Meg-Ohm bridge method. Sir, what is this Meg-Ohm bridge method? Concentrate. Sir, very simple, yeah. Just like our Wheatstone bridge. This is R1, R3, R2, R4, and supply voltage E, galvanometer. Okay, one is unknown, anything is unknown. Very simple here. Vary the available variable element until the galvanometer shows 0. It implies which condition here? Balancing condition. Over. After that, simplify. Already we have taken here. What is the balancing condition? If you simplify this, you will be getting R1, R4 equal to R2, R3. That is the reason why I spent a lot of time in the Wheatstone bridge method concept. Wheatstone bridge method, complete analysis and varieties of question you have taken. Same thing here also. But for differentiation purpose, I have taken PQRS there. Here R1, R2, R3, R4. That's it. But people are asking, sir, both bridges are looking like same only. How can we differentiate? Very simple. This is Meg-Ohm, high resistance, means this is high resistance. Sir, as it is high resistance, other three resistances are also should be in higher range only. Suppose if I take this is 0.1 ohm, this is 1 ohm, this is 2 ohm, do you get R1 as mega ohms, etc.? Definitely no. That's why simply by looking at the bridge circuit values, if medium resistance combination is there, they will mention mega ohm resistance or meg ohm resistance, means high resistance values are there. That is simply called as meg ohm bridge, nothing more than that. That's why I told you high resistance measurement is very, 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 very simplest method compared to all other methods. This is the total discussion regarding which one here? resistance measurement. That is low, medium, and high. Topic to topic, where the questions are possible, I have taken all varieties of questions. Now, in this high resistance measurement, where the questions are possible, let us see now. Right. Take 1 or 2 minutes of time, read this question and tell me the value. Make it. Try this. Very good, very good. Many people give the answer. Direct substitution here. Direct formula substitution only. What is it? Let us see now. Sir, here, laws of charge method. Clearly he mentioned. Okay, laws of charge method. Capacitance is 600 picofarad and voltage is 250 to 92 means 250 V in 92 VC means it is getting discharged no in 1 minute of time. But here very much careful. R is equal to T by C into ln VI by VC. So T 1 minute we should not take here. 60 seconds in terms of seconds you take it. And 600 pico minus 12 ln 250 by 92. You'll get the answer directly. So many ohms. Right. Mufti Sarwar, option B. No, yeah, kindly check it. You'll be getting option C. Which are VC and VI. Concentrate, dropped voltage. VC, large voltage VI means it is getting dropped. Discharging means 250 up to that it is taken. After the discharge means up to 92 means VC is 92. That's what the point. What is it? 100 into 10 power 9 ohms. Nothing but 10 power 11 ohms. Right. Got it? So this is the total discussion regarding measurement of resistance. Measurement of resistance. Clear? Right. Now, let me take 1 or 2 questions just for practice purpose. Some extra questions which are related to error analysis and this one. I'm expecting correct answer from everyone because we have taken so many times this model in the error analysis. I'm expecting correct answer from everyone. Still few people are giving. Many people are giving wrong answer. Concentrate. You are missing one word. What is that? Uncertainties. Uncertainties means random. This is not maximum here. This is just uncertainty means random. You are missing that. Kindly concentrate. I told you many of the questions also we solved. I gave the homework questions also on this. Kindly concentrate here. What is it? Here Z1 is equal to Z2 by Z2 Z3 by Z4. This is 1%, 1%, 3%. People are taking like this plus or minus 1%, plus or minus 1, plus or minus 3, therefore plus or minus 5%. Wrong. Why? He has given the values errors in terms of random family. Concentrate guys, random family he has given. So be clear, don't forget. I stressed more. I spend more time on this. I spend more time on this. What is it here? Uncertainty. Uncertainty in Z1 is equal to, what is it here? Root of Z2 to the power 1 into Z2 error 1% percentage outside plus Z3 to the power 1 to the power, nothing is there, no one, into 1% error square root a percentage outside. Z4 also to the power 1 only. What is Z4 error? 3%. So what is it? 1 into 3 whole square. So answer is plus or minus root 11%. Kindly concentrate. So many times you have taken this model, but still many people give that option C. No. Right. Vishnu Ajit, one of the classes you mentioned that uncertainty as limiting error. No, I did not mention here. This is what the main problem. I mentioned maximum uncertainty is equal to percentage limiting error. I told you. Uncertainty I mentioned as random error. Kindly don't make the statements like I made like that. No, go back and watch the videos and watch the follow the notes also. Kindly don't make the statements like this. Kindly. Yes, got it, Vashishta, correct. Maximum uncertainty is percentage limiting error, but not the uncertainty. Kindly concentrate. Starting chapters, right? You forgot that. What is this? What is this? Starting chapters means you need to concentrate more and more. So no, don't forget. Don't forget. Yes. Clear? So this is the total discussion regarding which one here? The resistance measurement. But few people are having the problem in this. Whatever the experiment I have taken here in the loss of charge method, same concept only he explained. Same. If any problem with English, I'll explain. No need to worry. Right here. Concept. What's it? No. A length of cable is tested for insulation resistance by loss of charge method. Okay. Insulation resistance is there. An electrostatic voltmeter of infinite resistance is connected between the cable conductor and earth. Means here, where he has connected? Here. I told you no, instead of this, electrostatic voltmeter also connected cable conductor and written path means earth. In that way, he has connected. Okay. I told you already, electrostatic voltmeter also will be there. And forming a joint capacitance of 600 picofarad. Yes, here, forming a joint capacitance 600 picofarad. It is observed that after charging, after complete charging, if you remove the supply, what is that? The voltage falls from 250 to 92, means discharging time. 250 was charged, it is discharged to 92. So that's why this is 92, this is 250, this is 600 picofarad. time in 1 minute he has given. That only, whatever the concept I told, same thing he explained in the question, nothing more than that. Definitely, always you have to take in terms of seconds only in the loss of charge method, seconds only. Otherwise, I will write here seconds, because second is the actual time, actual unit for time. Clear? Right. I'm giving one homework question today. Kindly get this answer. Take this as a homework. Yeah, very good question. Don't know why always the capacitor plays major, means inductive. Inductive means harmonics will be there. Inductive means lagging component. Always we prefer leading based component. Very simple logic, nothing more than that. Capacitor, good power factor, and capacitor, no harmonics at all, means what we can say, no noise at all. In that way, the capacitor is always leading type element. It is best always. That's not the point. Right. I'm giving now, see. I'm giving which is wrong, because 100 people, if you solve this, 90% of the people say that 100 is the answer, but 100 is the wrong answer. But which is correct? Which is correct? I'll tell you. Which is correct? I'll tell you. Right? Answer is 100 is not correct. So that's why kindly proceed. 100 you will get, that is wrong answer. But what is the answer you think of? So this is the homework question for today's class. Now, I'm stopping the lecture. Let us have the doubt session now. Today mostly numericals only we have taken. I'm not asking you to give the answer right now only. Take it as a homework means homework only after the session. I'm expecting at least one day, no one should ask the doubt. But every day people are ready. Means I'm getting doubt like, am I not clear? You're not listening. That's what my doubt actually. That's at least one day, sir, everything is clear, sir, no doubt. Means that is the actual day.
సార్ గుడ్ ఈవినింగ్ సార్.
యా
సార్ మెగ్గర్ ఉంది కదా సార్, అది మనకి స్కేల్ లో డైరెక్ట్ గా హోమ్స్ చూపిస్తుంది కదా సార్?
ఏంటి
మెగ్గర్ లో మనకి డైరెక్ట్ గా స్కేల్ లో హోమ్స్ చూపిస్తుంది కదా?
అది కన్స్ట్రక్షన్ మోడల్ చెప్పాను. బట్ మీకు ఈజీగా అర్థం అవడానికి నేను ఏం చేశానంటే వోల్టేజ్ సర్క్యూట్ సెపరేట్ గా, కరెంట్ సర్క్యూట్ సెపరేట్ తీసుకుని చూపించాను. బట్ మీ మెగ్గర్ లో ప్రాక్టికల్ గా అది ఉంటుంది. అది ఎప్పుడంటే ఈ ఆబ్జెక్ట్ పేపర్ కి అంత కన్స్ట్రక్షన్ అవసరం లేదు అనమాట. అది కన్వెన్షన్ లో చెప్తాను చెప్పాను. బట్ మీకు అర్థం అవడానికి ఫార్ములా వైజ్ ఇలా చూపించాను జనరల్ గా. బట్ ఈ వోల్టేజ్ యాక్చువల్ అయితే పొటెన్షియల్ కాయిల్, కరెంట్ అవన్నీ ఉంటాయి దాంట్లో.
ఓకే సార్. సార్ వెస్టర్న్ బ్రిడ్జ్ లో డౌట్ ఉంది సార్.
ఏంటి డౌట్
సార్? అక్కడ వోల్టేజ్ డివిజన్ అసలు చెప్పండి సార్. అంటే బ్యాలెన్స్డ్ కండిషన్, బ్యాలెన్స్ కండిషన్. సార్ ఒక డౌట్ సార్, ఇక్కడ తీసుకున్న రెసిస్టెన్స్ అన్ని ఈక్వల్ రెసిస్టెన్స్ వేరే వేరే రెసిస్టెన్స్ తీసుకోవచ్చు వెస్టర్న్ బ్రిడ్జ్ లో?
ఈక్వల్ తీసుకున్నా పర్లేదు, ఆపోజిట్ మల్టిప్లికేషన్ తీసుకుని ఈక్వేట్ చేసినా పర్వాలేదు. దట్ డిపెండ్స్ ఆన్ ద కండిషన్. బట్ బ్రిడ్జ్ మస్ట్ బి బ్యాలెన్స్, దట్స్ ఇట్.
ఓకే ఓకే సార్. అంటే ఇప్పుడు PQ ఈజ్ ఈక్వల్స్ టు RS అయినా బ్యాలెన్స్ అయినట్టు సార్ బ్రిడ్జ్?
PQ ఈక్వల్ టు
RS?
నో కమ్ ఆన్, అరే ప్రూవ్డ్ నో హియర్. PS ఈక్వల్ టు RQ. హియర్ PS ఈక్వల్ టు RQ ఉంటేనే బ్యాలెన్స్డ్. అందుకని మీకు ప్రూవ్ చేసిన తర్వాతే షార్ట్ కట్ చెప్పాను. ఆపోజిట్ బ్రాంచెస్ మల్టిప్లికేషన్ షుడ్ బి ఈక్వల్ టు అదర్ ఆపోజిట్ బ్రాంచెస్, బట్ నాట్ సేమ్ దీస్ టు నో. That is possible when if all resistors are equal, but that is not the condition. Always opposite only we have to take.
ఓకే సార్. సార్ అంటే సిడి దగ్గర మన గ్యాల్వోమీటర్ జీరో కరెంట్ అయినప్పుడే మనం వోల్టేజ్ డివిజన్ చేస్తాం సార్, లేదంటే వోల్టేజ్ డివిజన్ చేయలేం కదా?
వోల్టేజ్ డివిజన్ ప్రాక్టికల్ అంటే మనం మ్యాథమెటికల్ గా ఇంతకుముందు ఏం చెప్పాను నేను, ఈవెన్ దో ఇట్ ఈస్ అన్బ్యాలెన్స్డ్ క్వశ్చన్ చెప్పాను కదండి, even though it is unbalanced circuit, we apply the voltage division law, but it is not zero. I'm mentioning. Other than
Okay.
that, there is no other procedure. I told you no, that's not.
ఓకే సార్. ఓకే సార్, మళ్ళీ ఈ క్యూ దగ్గర ఉన్న వోల్టేజ్ డ్రాప్ పీ కి ఎలాగ ఈక్వల్ అవుతుంది సార్? ఎప్పుడు ఈక్వల్ అవుతుంది అక్కడ? అది అర్థం కాలేదు. అంటే ఒక సమ్ చేశారు కదా సార్, అంటే 2 volts ఉంది, అది 1K హోమ్ రెసిస్టెన్స్ దగ్గర 2 volts అపేర్ అయింది. అది ఎలా చేశారు సార్? అర్థం కాలేదు.
What is the voltage across this? VP. Okay.
VP sir.
What is the voltage across this?
VR.
Both will be same or different?
Okay. Parallel same sir.
Parallel కాదు, ఈ CED సేమ్ అయితే అది చెప్పాను క్లియర్ గా, ఆల్రెడీ చెప్పాను పాయింట్. VQ ఈజ్ ఈక్వల్ టు VS. ఈ రెండు ఈక్వల్ అయితే ఈ రెండు కూడా ఈక్వలే. మీకు వాల్యూస్ కూడా తీసుకొని చూపించాను. ఇక్కడ 10 అలాగే ఉంది, నీకు ఎరేజ్ కూడా చేయలేదు. ఇఫ్ యు టేక్ 10, this is 4, this is 4. If these two are equal, 6 only will be there. 6 plus 4, 10. 6 plus 4, 10. These two are equal, these two will be equal. Based on that only we have done so many questions also. Now I'm getting doubt, like, did you clear with all the questions?
Sir, అంటే కొన్ని అర్థం కాలేదు సార్ సమ్స్.
ఓకే, ప్రాక్టీస్ చేయండి ఒకసారి. క్లాస్ అయిపోయిన మళ్ళీ మీరు నెట్వర్క్ బేసిక్స్ ప్రాక్టీస్ చేస్తే అర్థం ప్రాబ్లం లేదు.
ఓకే సార్.
Hello sir.
Hello sir.
Yeah.
Sir, I had a doubt in yesterday's problem, sir. I was revising. Sir, in yesterday's current transformer, sir, there was a vector addition thing, sir. The primary current equal to no load current plus secondary current referred to the primary, sir.
Yeah.
In that,
did you attend my doubt session yesterday?
Yes, sir, I attended, sir.
One student asked the same doubt.
Yes, sir. Yes, sir. One same student asked the same doubt, but I still didn't get it, sir.
Huh?
Sir, in that, I still couldn't get it, sir.
Yeah, tell me. What's the doubt?
Sir, so in that, yesterday, as you explained, sir, the student also asked that for vector addition, there's a formula, sir, a square plus b square plus 2ab cos theta. But here, as the angle between them is not 90 degree, how are we getting the primary
same
magnitude?
Question she asked, same question I answered also. Same question she asked. Why 90? I have not taken 90. I have taken only magnitude. I have separated the angle. I told you this example also. Suppose one circuit is there. This is 3 volt. This is 4 volt. What is this voltage?
Sir, but here it will be 5 volt, but we know that the voltage across the resistor is in quadrature with the voltage of the inductor, sir. Here we know that they are in quadrature.
Yeah. Then?
Sir, then if they are in quadrature, the angle between them is 90 degree, sir.
Okay.
Here, sir, if it's in 90 degree, then cos theta will be 0, and we'll get root over of 3 square plus 4 square, sir.
Okay. This is I0. Okay,
yes,
right?
Yes, sir.
And this will be I2, for example.
Refer to primary will be I2 dash.
IS dash. Okay.
IS dash, yes,
You
sir.
added these two. Then
Yes, sir.
tell me.
Yes,
This
sir.
is
Here
IP.
IP, yes, sir. Here, like, if you consider what the angle between I0 and IS dash, any angle, sir, but if it was 90 degree, then you would have got IS.
It is your I got. Very simple. You are
No, sir.
missing small point. See, what is the why? Correct. This is vertical is being taken. This is delta. Got it here? Who is this?
Yes, sir.
Got it? Right. Okay. What is this? Alpha. Alpha and delta. Very, very less. I told you.
Okay, sir. Yes, sir. They are very less. Yes, sir.
That's in that question. Alpha, delta, he has not mentioned. If he has not mentioned, automatically between these two, approximately. No problem.
Okay.
I told you one more point also. 1 second. If delta and alpha are mentioned in the question, substituted. Otherwise, treat them as 0 over.
Okay, sir. I got it, sir.
Right.
Thank you, sir.
Hello, sir.
Yeah.
Hello, sir. Sir,
Yeah.
in 34F, sir.
34F. Okay.
Sir, sorry, direct deflection method once again
Yeah.
explain. Yes, direct deflection method.
ఏం డౌట్ అమ్మా?
సార్ అక్కడ ఇప్పుడు మనం ఎందుకు సార్ మెగ్గర్కి వెళ్తున్నాము డైరెక్ట్ డిఫ్లెక్షన్ లో లిమిటేషన్ నేను ఒకసారి
ఆ లిమిటేషన్ డౌట్ ఉందా?
ఎస్ నెట్వర్క్ ఇష్యూ.
Okay. See, simple. This is 10 volt ammeter resistance is placed. Suppose this is 0, 1, 2, 3, 4 for example. Some
Okay.
scale is there. Assume that this is 1 microampere. 1 division equal to 1 micro for example.
ఓకే
What is R value? Pointer is showing one division. For example, 10 by, what is that? 1 micro ampere. So therefore 10 by 1 micro means 10 mega ohm measure. Okay, no problem. Suppose in the second one, if I'm keeping R2 which is greater than 10 mega ohm, which is greater than 10 mega ohm, then the current will be less than this first division. If it is less than first division, can you write any current value? No. Can we get a resistance value? No. That is the reason why we need to go for variable voltage, the two large voltage application into. That's why instead of this generator we use. That's it.
ఓకే సార్ ఇన్ మెగ్గర్ లో కూడా మనకి ఇలా డిఫ్లెక్షన్ వస్తుంది అప్పుడు మనం వోల్టేజ్ పెంచుతాం కదండి సార్.
ఏంటమ్మా?
మెగ్గర్ లో కూడా 1 మైక్రో ఆంప్స్ కంటే కూడా లెఫ్ట్ సైడ్ కే డిఫ్లెక్షన్ వస్తుంది వోల్టేజ్ పెంచడం వల్ల.
రైట్, ట్రూ, వెరీ గుడ్, నైస్.
సార్ అది నాకు కూడా వోల్టేజ్ డివిజన్ రూల్ డౌట్ ఉంది సార్ కొంచెం. అది ఇప్పుడు ఒక క్వశ్చన్ లో ఏమో మనము పీను ఆర్ రెసిస్టెన్స్ ఆర్ వోల్టేజ్ సేమ్ తీసుకున్నాము, ఇంకొక క్వశ్చన్ లో పీక్యూ
all voltages I have not taken blindly. He has mentioned before the break I gave you, right, that question. He has mentioned, yeah, he has mentioned. What he has mentioned? R1, R2, R3 equal to R. R1 equal to R he mentioned. R2 equal to R he mentioned. As one second, as he mentioned, I have taken E1 equal to E2. Suppose he has given that this is R5, this is R6, like that, I cannot take. So that's why I told you clearly from the circuit, E1 equal to E2. Why? I1 into R, I1 into R equal. Isn't it? Suppose 10, 15, 20 different values. Clear?
ఎస్ సార్. సార్ ఇప్పుడు బ్యాలెన్సింగ్ కండిషన్ లో మనము P by Q ఈక్వల్స్ టు R by S తీసుకుంటే వోల్టేజెస్ సేమ్ తీసుకోవాలి, అది ఒక్కసారి చెప్పండి.
అర్థం కాలేదు.
బ్యాలెన్సింగ్ కండిషన్ లో ఏ వోల్టేజెస్ సేమ్ ఉండాలి ఈ ప్రాబ్లం లోనే చెప్పండి.
దీంట్లో రైట్. ఇక ఏంటి? R equal to P by Q తీసుకోండి. Which voltages? Simple logic. See, very simple here. Very simple. Don't get confused. నెట్వర్క్ ఏర్ అయిపోయిందమ్మా మీకు?
లేదు సార్.
అందుకని ప్రాబ్లం టెన్షన్ ఏం లేదు. VC equal to VD మన ఫస్ట్ టార్గెట్. Other people listen. Our first target is VC equal to VD. VC equal to VD. VC2 you are going to B or you are going to A, that is your wish. Suppose if I say VC to VB, that is VQ, then VD to VB only have to go. That is VQ equal to VS I have written. Okay? Otherwise, ఇంకో మెథడ్ చెప్పాను, రెండు మెథడ్ చెప్పాను. ఇక్కడ ఏంటి? I'm going from VC to VA, no problem. That is VP. VC to VA, VR. I have taken this. VP equal to VR, V equal to VS. Answer will be same, no problem. That's why from this terminal, from this node, where you are going, that you have to take every time. To B only. Otherwise, to A and to A only. That's all.
Thank you, sir.
Right.
Sir, in 20F, sir.
I'm allowing you to.
20F, sir. Hello, sir.
Yeah.
సార్ ఇక్కడ చేంజ్ ఇన్ రెసిస్టెన్స్ మామూలుగా 10/1000 తీసుకోకూడదు అని చెప్పారు కదా సార్ మీరు, అది ఒకసారి చెప్పరా సార్, నాకు అది అర్థం కాలేదు.
No problem. Very simple. First see the question. In this question, what is the unit he has given? Volt per ohm, volt per ohm, volt per ohm. Okay,
Yes, sir.
that's why always the sensitivity of anything depends on that particular task, that particular given condition. He is asking volt per ohm. Suppose if I take here 0.25 minus 0 by 10 by 1000, if I take for example, what is that? This is
Only volts లో
millivolt.
ఉంటుంది.
No unit will be there, no.
None of the above కూడా
That's
option
what I told you. That's what I told you. When you have to go for none of the above means if basic condition is not satisfied with all the three, if this is wrong, this is wrong, this is wrong, then only you have to go. But I told you, what is that? Sensitivity has plenty of units based on the condition. If any one condition related sensitivity is satisfied, then you need to think of these three. If these three are not matching with any of the combination of sensitivity definition, then you have to go for none. That's why to kill your time for negative marking point of view, none of the above is given. Because generally people think like sensitivity means delta or where none of the above. No, what is it? None of the above. What is the meaning of none of the above? If above three are not correct, then only we go for none of the above. That's the actual meaning. But
yes, sir.
here sensitivity meaning any one of the units are possible. First you verify that, then go for it. That's it.
Okay, sir. Okay, sir. Understand, sir.
Got it?
Hello, sir.
Yeah.
Sir, today's in bridge sensitivity derivation, sir.
Huh?
Sir, once open the bridge sensitivity derivation, sir.
Which is sensitivity derivation. Okay. Bridge sensitivity derivation. Yes. Yeah.
Sir, this derivation I understood, but this derivation looked some clumsy, sir. Can you please?
You need to practice. Total expression is not possible, right? Almost half an hour topic. Where you have doubt,
No.
that you tell me, I'll explain.
No, sir. You just mentioned those like SVSI like that, sir. You just mentioned those in derivation.
I'm not getting your doubt. What is your doubt? Tell me the point.
Sir, I understood this derivation, sir, but from where did you substituted that all?
From where you substituted? Did you attend the total session?
Yes, sir.
Then what's your problem? I'm asking. Don't take negative. I'm asking. See, you're asking something. What should I explain? I need to understand, right? That's why. Which point is your doubt? That I'm asking.
Sir, first you took a balanced bridge.
Yeah.
And then you took PS is not equal to Q into R plus delta.
I got your doubt. See, understood that you did not understand this entire topic. I'm clear that, no problem. First, sensitivity means what? How the pointer is deflecting with the change in resistance. Okay. First, I have taken balanced bridge. Under the balancing condition, pointer is showing 0. After that, one of the resistances I have changed. With this change in resistance, automatically pointer will be getting deflected. How it is deflected? With that, we need to determine the sensitivity. First, I have taken. Actually, this is not required. For idea purpose, yes, initially the circuit is balanced, I assumed. After that, from 0 to this one, it is gone. From 0 to this one, it is gone. Automatically, I can define the sensitivity. Clear first point? Now, I have gone to unbalanced. I'm explaining total thing. I understood. See, Sai Charan, don't get hesitated first. Sai Charan.
Okay, sir. Okay, sir.
Hello? మీరు ఉన్నదే డౌట్స్ అడగడానికి కదా ఎందుకు హెజిటేట్ అవుతున్నారు అది డౌట్ ఇది క్లియర్ గా అడగండి ప్రాబ్లం అంటే నాకు తెలియాలి మీకేం డౌట్ ఉందో అది హెజిట్ అవ్వద్దు చెప్తాను నేను అయ్యో మొత్తం అని అలా కాదు నేను ఎందుకంటానంటే మొత్తం చెప్పడం కుదరదు ఎందుకంటే మిగతా వాళ్ళు నెక్స్ట్ టైం అలర్ట్ అవుతారు కాబట్టి అంతే తప్పితే మీ డౌట్స్ క్లారిఫై చేయకపోతే నేనే ఫీల్ అవుతుంటాను అయ్యో క్లారిఫై అందుకని జాగ్రత్త వినండి నెక్స్ట్ కండిషన్ ఏంటంటే I'm taking this resistance change by how much? Delta plus R. Automatically, yes, P into S, Q into R plus delta. Definitely no. Why? What is the initial stage? Q into R, this is equal. Definitely not equal. Then bridge is not balanced. If the bridge is not balanced, If the bridge is not balanced, automatically, one second, kindly, okay, right, here. If the bridge is not balanced, the difference in this voltage VC and VD will not be zero. I applied the voltage division law. I have taken these two voltage and I have taken these two voltage here. That's it. After that, I wanted to bring all terms into single. What is that? RS, RS. That's why Q by P plus Q, I substituted S by R plus S. Because values, those values are same only. I have taken that. And not equal to 0. Simple cross multiplication I have taken. After this, I neglected the delta R. I have neglected the delta R. Be clear, this second process is after changing the resistance. So that, okay, if I change this much of resistance, point of deflection is this much, so that we can define the sensitivity. Further, simple mathematics have taken. In the bridge sensitivity formula, E into SV by delta R by R. Why? E into SV is delta theta. I substituted that one. Nothing more than that.
Okay,
After
sir.
that,
I got this, sir.
Yes, very good.
Sir, in here, magnitude of E is equals to V0 is equals to V02 minus V01. Here,
Yeah.
V01, why did you neglect, sir? Minus V01.
Are, come
Yes,
on,
sir.
come on. Here, what is this? What is this channel?
Yes, sir. Oh, yes, sir.
Okay, if you want me to
So
write,
V01 means
because V01 means
V01
under
means in
balancing condition. V02 means after
yes, sir.
disturbing the circuit.
Yes, sir.
Clear?
I thought.
What happened?
Hello.
Yeah.
Yes, sir. I had a doubt in question, sir.
Which question?
Actually, sir, in expected volume questions, sir, in that book, their question was given, sir, about electrodynamic ammeter, sir.
Okay.
Hello.
Yeah,
There they have given the value of initial inductance, sir, at 0 degree Celsius. Sorry, at 0 degree theta, and they have asked to calculate at full scale deflection, sir, at 110 degree. So now, and they have asked to calculate the change in impedance, sir. Then change in impedance is equal to
where you have
sorry
seen this
mutual
question? One second.
mutual
Where you have seen this
impedance,
question?
mutual inductance, sir. Sorry,
Where
mutual
you have
inductance.
seen this question? One second. Where you have seen this question?
In volume 2, sir, most expected questions with solution, sir, provided by S.
Yeah, kindly send that question once immediately to my number. I'll clarify because I have to see the question once.
Yes, sir. Actually, and that, sir, day before yesterday's question also, sir. I
Did
had
you
asked
send me?
you.
You
Yes,
send
sir.
me?
I had. Yes, sir. That day I sent you, no, sir.
This wattmeter question is sent.
No, sir. This.
You send me this question once. You send me this.
Yes. Wait. One
Yeah,
minute.
you send after I receive. I'll clarify. Don't worry. Don't get tensed. Who is this?
Hello, sir.
Yeah.
Hello. No.
Who is
Hello,
speaking?
sir. Priyavrat, sir.
Yeah. Okay.
So actually, I had a small doubt from the 2-watt method
Huh?
numeric. 2-watt wattmeter method numerical. You did 3464 volt ampere apparent power. That
Yeah.
question. Sir,
What is your doubt
actually,
in that?
sir, doubt is that why we haven't taken here directly the voltages in the RYB sequence.
We have taken direct voltage. No, we have taken
Yes,
400 volt directly.
No, sir, angle. Why we have to draw phasor in this? Because in earlier question also you took direct the angles, angle 0, then minus 120. So in this question, why we have to draw the phasor? Why
Has he given balanced band supply in this question?
So load is balanced and inductive.
Load is balanced.
Okay.
But what about the source?
Okay, sorry. Yes, I
Very
got
good.
it.
Good question. Good thought. No problem.
Okay, sir.
Right.
Thank you.
హలో
Pratyush.
సార్.
Yeah.
సార్ సార్ ఆ క్వశ్చన్ పంపాను కదా సార్.
Huh?
సార్ అదే వాట్ మీటర్ క్వశ్చన్ పంపాను కదా సార్, సింగిల్ ఫేజ్ వాట్ మీటర్.
చూడలేదు. నేను అడిగాను మీది.
అదే సార్, అంటే ఇప్పుడు నేను అంటే మీరు ఇచ్చిన ఫార్ములా బట్టి అది అవుతుంది, అంటే L²/VL²/RPB ఆ ఫార్ములా బట్టి యూస్ చేస్తే
కరెక్ట్. అయితే మీరు ఏం మిస్ అవుతారు? సింపుల్ లాజిక్. అక్కడ మనకి కరెంట్ కాయిల్ ఇంపెడెన్స్ గానీ పొటెన్షియల్ కి ఇంపెడెన్స్ కానీ ఇవ్వలేదు. మనకు ఓన్లీ ఏమి ఇచ్చారు? రెసిస్టివ్ నోటేషన్ ఇచ్చారు కాయిల్స్ కి. అవునా? కాయిల్ ఆర్సిసి అండ్ ఆర్పిసిని ఎల్పిసి అండ్ ఎల్సిసి ఎల్పిసి ఇచ్చారు క్వశ్చన్ లో?
ఇవ్వలేదు సార్.
ఇవ్వలేదు. అంటే ఏంటి? ఇండక్టివ్ నెగ్లెక్ట్ చేస్తున్నారు కదా. అందుకని కాయిల్ స్ట్రక్చర్ తీసుకునేటప్పుడు ఇండక్టివ్ నోటేషన్ నెగ్లెక్ట్ చేస్తాం. అందుకని ఆ కాస్-ఫై ఎఫెక్ట్ అనేది కాయిల్స్ పైన ఉండదు. ఎందుకంటే ఇది నెగ్లెక్ట్ చేస్తున్నాం కదండి. మీరేం మిస్ అవుతున్నారంటే పవర్ ఫ్యాక్టర్ లోడ్ ఉంటుంది. విఎల్ ఐఎల్ కాస్-ఫై ఓకే, బట్ ఈ పవర్ ఫ్యాక్టర్ అనేది ఎల్ఎల్ అని నెగ్లెక్ట్ చేస్తున్నాం కదా మీరు రెండింటిని. రెండు రెసిస్టివ్ కాయిల్సే కదా, ప్రాబ్లం లేదు కదా. అప్పుడు అర్థమైంది? సింపుల్ పాయింట్.
ఒకవేళ ఇస్తే సేమ్ పవర్ ఫ్యాక్టర్ అయ్యేదా సార్?
100% మీరు ఏ క్వశ్చన్ తీసుకున్నా ఎల్సిసి ఎల్పిసి ఇవ్వరు. ఒకవేళ ఎల్సిసి ఎల్పిసి ఇచ్చినప్పుడు ఎస్ యూ హావ్ టు టేక్ ద పవర్ ఫ్యాక్టర్, బట్ ఇన్ ద ఆబ్జెక్టివ్ పేపర్ క్వశ్చన్ పాయింట్ ఆఫ్ దే డోంట్ గివ్ జనరల్లీ. ఇస్తే తీసుకోవాలి. సింపుల్ పాయింట్.
ఓకే సార్. ఓకే సార్. ఓకే సార్, థాంక్యూ సార్.
మీకు ఓరల్గా చెప్దామని ఆగాను, ఎందుకంటే నేను టైప్ చేయలేను కదా ఇవన్నీ, అందుకని.
అదే సార్ అనుకున్నాను సార్.
గుడ్.
Hello, sir.
Yeah, got it. Admin?
Yes, sir.
Yeah. I'm seeing yours only. 1 second. What is the given data? 10 ampere dynamometer. Okay. Spring constant 0.1 into 10 power minus 6 Newton meter per degree. Okay. The full scale deflection theta is given and determine the index. Question is not completely sent, I think.
Sir, I have sent the second photo, sir. Actually, I had the doubt in last part, sir. They have asked.
Question. 1 second. Okay. Change in inductance of the instrument when measuring a current of 10 ampere. Mutual inductance at 0 degrees deflection. Okay. Theta is equal to 0. Mutual inductance is 2 microhenry. Okay. And change in what is the doubt?
Sir, my doubt is they have asked the change in inductance, sir. Change in mutual inductance, and in solution they have added, sir, both inductances.
Okay. That is your doubt. Okay. 1 second. Let me go to the question. Determine the inductance. Come on here. Not change inductance. See the question. In first figure, determine the inductance of instrument when measuring a current of 10 means full scale value they are measuring. Initially something is a change in. Come on here, admin. In the first picture, last one. Determine the inductance, not change in. Concentrate.
Yes, sir. Yes.
Then add it definitely. This initial value, change in inductance will be there.
Yeah. Last value they have asked.
Yeah. That's what.
Okay. Thank you, sir. Thank you.
Right. Very good. Okay then. Tomorrow, same time, we are going to start AC bridges. All people, right? Down the hands, no problem. Very good.
Hello, sir.
Yeah. Who is this?
Sir, sir, I am Yogesh, sir. Yogesh.
Yeah.
Sir, that previous question remains, sir. You did not answer.
Okay, admin. Yeah. 1 second.
Day before yesterday, I have.
1 second. Actually, I have not gone through. You written this one. Yeah, you written this question. Yeah, actually minus in. Okay, sorry. I'll see that and tell you, because minus in you asked yesterday, right?
Yes, sir. Yes.
Yeah, I'll send you. No worries. I'll send you.
Yes, sir. No problem. Thank you, sir.
Okay then. Thank you and all.